So in this Kubernetes tutorial, what we are going to study is we are going to study a complete Kubernetes architecture and all those different commands. We are going to study what is Kubernetes. We are going to understand its architecture, why there was a need of Kubernetes. We are also going to understand the different components of Kubernetes, what all the different components means and how we can create the different components in Kubernetes architecture. We are also going to create the different Kubernetes YAML configurations. So with those configurations, whatever the application that we have created, how we can use the custom images to create our Kubernetes architecture, and with those YAML configuration, our entire application will be deployed to our Kubernetes cluster. So these are all the details that we are going to cover in this tutorial. So it's going to be a pretty comprehensive and we are going to learn a lot of things. So first we need to understand what is Kubernetes, and before understanding Kubernetes we need to understand why there was a need of a Kubernetes. So first let's go back to the history and see how the traditional deployment was happening. In the traditional deployment, what we used to have was we used to have our hardware, and on top of the hardware we were having our operating systems, and on top of our operating system we were deploying our applications. There might be different applications and all those different applications were deployed all together on our operating system. Now with this approach there was a limitation, like suppose my one application is using the Java 8, my another application is using Java 11 and other application is using Python. Then to maintain all those different versions and everything was little bit cumbersome. Okay, and the proper utilization of the resources was not happening. So for that reason virtualization comes into picture. Like on one hardware you can have multiple different virtual environments and you can use virtual environments to complete or to deploy your applications. In the virtualized deployment, what we used to have was we used to have our hardware, and on top of the hardware we were having our operating system, and on top of the operating system, whatever the OS that we were using, on top of that there was a virtual layer, okay, which provides us to have the virtual environment on top of our system. Here I'm taking the example of the hypervisor. So on top of the operating system we were having the hypervisor, and on top of the hypervisor we have the different virtual environments. So you can see that we can have multiple virtual machines on top of our hypervisor layer, that's on top of our operating system, and this virtual environments or this virtual machines will also have its own operating system, and on top of them we can have different libraries installed, whatever is required, and on top of that we can deploy our application. So in one virtual environment I can deploy my Java 8 application and Python application. In another environment I can deploy my Java 11 application and Java 17 application, and so on. So this way both the environments are different, so there is no conflicting environments or conflicting results. So it's pretty smooth than the traditional deployment. But here you can see that on top of our hypervisor we have virtual machines, and that virtual machines also uses its own operating system, and with the operating system there is a lot of things that comes into picture. So you can see that there is a lot of resources utilized by the operating system and the different things involved in that. Okay, so the proper utilization of resource is not happening. I just want to deploy my application. I don't want that there is an extra layer of resources been used by the operating system and everything. So to avoid this overhead of the resource utilization by the virtual machines, the containerization comes into picture. So in the container deployment, what we have is we have our traditional hardware, and on top of the traditional hardware we have our operating system installed, and on top of the operating system we have our container runtime. There are multiple container runtimes available. Okay, so any of the container runtime we have on our operating system, and on top of that we have our containers installed or container deployed to our container runtime. Okay, there are many like Docker, Containerd, and many others are also there. But on top of our container runtime there is a containers, and those containers will have the libraries, and with those libraries we will be deploying our application. So you can see that the base of the container runtime is still our host operating system. Okay, a host kernel. So that means that the kernel and the operating system will remain the same, the kernel will remain the same. So if you have the Linux operating system, then you will be having the Linux kernel. So whatever the container runtime or containers that you are going to create, that will be also with the Linux only. So you can see there is no extra headroom that needs to be utilized by your containers. So you just define your containers and those containers will be deployed. Okay, easily. So earlier we saw that using the Docker we used to create the containers, and in those containers we were having our applications deployed. Now suppose you have a very huge application, okay, and in your environment you have hundreds and thousands of containers needs to be deployed. You need to maintain everything. So to maintain your entire life cycle of your containers by doing it manually, it's really difficult, right? So what if there is a tool that allow us to do all those things, managing all those containers by default? Okay, it allows us to maintain each and everything. It will orchestrate everything for us. We do not have to worry about anything. We just need to concentrate on developing our application. Deployment and everything will be handled by the application or by the tool itself. Okay, so for that reason Kubernetes comes into picture. Kubernetes allows us to handle or to orchestrate each and every containers that we have in our application. So if I have hundreds of application, and for each of different applications I have the different configurations, like this application should be connected to this environment, this application should be connected to this database, it should be connected to this Redis or Kafka or anything. All those configurations and everything should be configured. All those things and everything should be configured with Kubernetes, and Kubernetes will take care of each and everything to make sure that each and everything is running at all times. So that's the idea behind Kubernetes. Now let's see its architecture. Hey everyone, let's talk about something that we all deal with: passwords. How many of you struggle to remember them, or worse, to reuse the same password for your personal and work accounts? If at least one account gets compromised, it's game over. That's where NordPass comes in, created by the minds behind NordVPN, the world's leading VPN service. NordPass is an easy to use password manager designed to keep your business and personal accounts safe, secure and hassle-free. With NordPass, you can securely store your passwords, credit card details, and even get a real-time updates if your password is found in the dark web. You can safely share your credentials for autofill across your team members with just a few clicks without any hassle and without even sharing your actual passwords. It uses end-to-end encryption and zero knowledge architecture, so no one will be able to know your password until shared, not even NordPass themselves. It's super simple, plus it also works across all your devices. Simple, secure and hassle-free. Use the code dailycode at nordpass.com to get a free 3 months of NordPass business. Trust me, once you try it and once you are used to it, you will not go back to your sticky notes or emailing your passwords or keeping a note of your passwords. So stay secure and stay stress-free with NordPass. Go to nordpass.com/dailycode. Now back to the video. So if I give you the very basic, Kubernetes architecture involves two things, that is the master nodes and the worker nodes. So it will always have a master node that will control everything, and it will have the worker nodes that will work according to the master node. Okay, so that will be your entire Kubernetes cluster. In your Kubernetes cluster, that will be having multiple nodes, and one of them would be master. There might be multiple masters, but at least there should be one master and the worker node. And then in the worker nodes, you will be deploying your applications, your containers. Okay, and with the containers, there will be one Kubernetes component that is called a kubelet. So what kubelet will do is, kubelet will run on each and every node, and it will make sure that it has all the proper sets of information based on, or proper set of configuration based on the master node. So whatever the configuration and everything is been provided within the cluster, it will be handled accordingly. Now let's talk more about the master node, what it will be there in the master node. Okay, so master node will have the API component. So what is the API component? It's the API server or the front end part of the Kubernetes control plane. So whatever we will be doing in our Kubernetes cluster, everything will happen using the API. So we have the access to this API using the UI, or using the API itself, or using the CLI tool as well. So with either of the one, we can access the API server, that is the control plane of the Kubernetes. So whatever we have to do, like creating a pod, creating containers, doing some extra configuration, checking the logs, anything, we will give the commands to the API, and based on that, either of the one, that is a UI, API or CLI, we will interact with the Kubernetes. So that is one of the component in the master node of the Kubernetes cluster. The next come is the control manager. So control manager is the one that keeps tracks of each and everything happening in the Kubernetes cluster. So it is also divided into another 4 parts, that is the node controller, reputation controller, endpoints controller, and the service account and token controller. Okay, and from the name itself suggests that it will be doing the operation based on the name. So node controller will handle all the nodes, replication controller will handle the replication, like whatever the replication sets that you have defined, right? Like this particular application should have at least one node available or at least 2 nodes available. So it will maintain that whatever we have defined replicas, it will maintain those replicas and accordingly. Okay, endpoints will handle our endpoints, and service account and token will handle all the service account and token informations. So this way there are different controllers available, and all those controller will handle all the different operations accordingly. Then the next come is the scheduler. So scheduler will maintain the pod placement in our Kubernetes cluster. So if I have 3 nodes available in my cluster, and I will be just creating the pods within the cluster. So scheduler will handle that which particular pod should go to which particular node. So it will schedule based on the resources available or based on the configuration available, and it will place those pods within the actual nodes. So that scheduling and everything will be handled by the scheduler in our Kubernetes cluster. The next component in our master node would be the etcd server. So etcd server is a highly consistent and highly available key value store. It stores the information of each and everything happening in our Kubernetes cluster. So whatever the configuration or whatever happened till now in your cluster, everything will be stored in the etcd server, and from that we will get all the information. So we should always make sure that we have the backing store available for it. So we should always make sure that we have at least 2 master node available. So whenever there is issue with one of the master node, another node can act as a master node, and it will have all the informations that happen within the cluster. Internally it will handle each and everything. We do not have to worry about it, but we need to make sure that it has multiple master nodes. And how they will understand each and everything, because for each and everything like master node and the worker nodes, they will have its own virtual network. Okay, so everything will be happening within the virtual network within the cluster itself, and they can interact with each other. So you can see from the depict diagram that we will be having master nodes and the worker nodes, and connecting between them would be using the virtual network within that particular cluster environment. Now let's talk more about the worker nodes. What worker nodes will be having? Okay, worker nodes will be having the pod component. So pod is a single unit of deployable component in the Kubernetes cluster. So anything that we want to do within the Kubernetes cluster, we will be doing using the pod. So whenever I want to deploy an application, or whenever I want to deploy a container within the Kubernetes cluster, I need to wrap around with the pod, and that I can deploy. And whenever we will be creating the pods with the containers in it, whatever the application that we are going to start on that particular container within the pod, it will assign an IP address to it. So each and every pod will have its own IP address. Okay, so it's a dynamic IP address created. So whenever you create a new pod, the new IP address will be created to it. And as this IP address will be dynamic, we need some component which can have a static IP address, so our different components can connect to it. Okay, so for that reason we have a service component. So for multiple pod components, we can create a service component. So suppose if I have one application for the user management, so for that user management I can create multiple pods. All those multiple pods will be having its own IP address, but all those pods will be connected to one user management service. So whenever any other application wants to connect to that user management service, they can call using the service IP address or the service name itself. And with that service name, this service name will have the load balance service, so it can call all the services attached to it. So if I have 4 user management service attached to that service, I can call accordingly. So this was all about the Kubernetes architecture, where we saw the different components available in the worker node and the master node. Now let's talk about the different components available in the Kubernetes cluster. So we'll see the different components that are there in the Kubernetes cluster, and we'll understand what all these components means. So let's start with the worker node. We already saw that the worker nodes will be the nodes that will have the application deployed to it. And the next component is the pod. So I explained you briefly in the earlier video as well that pod is the smallest unit of Kubernetes component that can be deployed to the cluster. Okay, so you can see that these are the pods available, and all these pods will be having the different application. So consider that in one of the pod I have my application container, and in the another pod I have my DB container. Okay, so in one of the pod I have application, and in one of the pod I have database, and these are the abstraction to my containers. So within each pod I will be having the container. I can have one container as well and multiple container as well, based on the architecture or based on the design that you are using. And each pod will be having its own IP address. So here you can see that both the pods will be having its own IP address, and both the pods are connected with each other using the IP address available to it. Okay, now suppose one of the pod gets down. Okay, my application is down or my database is down. So what happens is, whenever the pod is down, the entire new pod is created, and whenever the new pod is created, it will have its own new IP address. So you can see that new IP address is created for the new pod, and now the IP address is different. So how your application will connect to the database or whatever the different pods you have, because the IP address is changed. It's not the static IP or a constant IP, it's a dynamic IP. So for that reason, we have the service component available. So whatever the pods that we create, for those pods we will create the services. Now this service will help us to connect all the different pods together, because service will also have the different pods attached to it in the load balanced format. Okay, now these services are available within the 2 different ways. It will be internal service and the external service. Now you can see that if any components are interacting within each other, it will be called as the internal service. So you can see that I have 2 pods available and both the pods are within the Kubernetes cluster. So both can connect together within the cluster. So for that we'll be creating the internal service, and the external service would be any request coming from outside of the Kubernetes cluster that I need to handle. So your application would be used by the external user, so any user can do the request to your application. So for that we have to create the external service, but no one would be doing the database access directly. So that will be only within your environment, within your application. So that's why that's going to be the internal service. And for the external service, we have the another component that we can use to create is the Ingress component. So Ingress component will allow us to create the external service, which will allow the traffic from the public internet or public network to your Kubernetes cluster. Now, whenever we are creating the different application, we'll be having a lot of different configurations as well. Like this particular application that I have, it should connect to which particular database, it should connect to which Redis environment, or a lot of different information. So a lot of configurations also we are going to add in our containers. And the container lifecycle is pretty unique, like it is going to be destroyed as soon as there is an issue with it, and the new pod is going to be created and the new configuration or new IP address is going to be created. So for that reason, what the ideal way to do is to handle the configuration separately. So we have the separate configuration component that is going to be called as a config map. So there is a component that's a config map which will allow us to add all those configurations. So all those configurations will be added, and we can have like all these configurations are being used in this particular pod itself and within this configuration. So that configuration we can define. So all the configurations are externalized and it can be used within the Kubernetes cluster. Now in our application, we are also going to use the sensitive data as well, like storing the passwords and the secret information and everything. So for that reason, we have the another component that is called the secret. So this secret will store the data in the base 64 encoded format, so it's not directly visible to anyone. So here we can store all our sensitive data like passwords, secrets, credentials and everything, and those can be used within the pod by the containers and the application to access those. Now as based on the pod's lifecycle, like whenever there is an issue with the entire pod will be deleted and the new pod is going to be created. So whenever we are storing data to the container or pods, like in case of the database, we are going to store the data, right? So whenever we are going to store the data in the database and the pod goes down and a new pod is created, it's not ideal, right? Because a new pod is going to be created and entire data is going to be wiped out, right? So for that reason, what we have to do is we have to attach the storage to that particular pod. So for that reason, we are going to use the volumes, and we can use different types of volumes available. So what we can do is like an extra storage is provided, and that storage will be constant, and the new pod is going to be created. And whenever the pod is going to be created, it will use the data from that particular volume. So whatever the data is stored till that particular point, before the pod was deleted or pod was crashed, that information we will be having. So with that, we won't lose any data. And we can use 2 types of storage available. That is going to be the local storage, that's going to be the inside the cluster. But what will happen is when we go ahead with this approach is whenever the cluster crashes or cluster is deleted, then our entire volume is also going to be deleted. So in that case, we can use the remote volumes or remote storage which is outside your cluster, and that we can use to connect our data. So there are different types of storage providers. All the clouds provide the storage to use within the Kubernetes cluster. So we can use those storage and attach our volumes to that storage. So whenever there is an issue with the pods or entire Kubernetes cluster, we won't lose any data. Okay. So this way also we can go ahead and attach our volumes to the pods available, and that volumes will be used whenever a new pod is also created. Now we already saw that whenever the pod is destroyed, we won't be able to access it, right? Your application is down. But our goal of using Kubernetes is to make sure that we have the highly scalable and highly available infrastructure, highly available applications, right? So for that reason, whenever any pod is down, we won't be able to access it. So for that reason, what we have to do is we have to make sure that there is a replica available, so we can directly access it. So it provides us to have the replicas available, so multiple applications or multiple pods running within the Kubernetes cluster. So we can have the multiple worker nodes, and on those worker nodes we can have the multiple pods running for our application. So whenever one pod is down, all the traffics will be routed to the another pod, so our application will be highly available. And whenever we have to do this, like we have multiple applications available and multiple pods and with pods available, and all those should be maintained uniformly, like within one component everything should be created, right? Because I do not want to create pod again, then service again, then create another pod and service and everything. Okay, everything should be streamlined. Within one component everything should be created and replicas and everything should be maintained. So for that reason we have the component called deployment. So within the deployment we can define everything, like this deployment will have this many number of containers, all those containers will be having minimum number of this replicas and everything, and all those information we can attach to the deployment. And whenever we will create the deployment, all those components will be created for us, so we do not have to manually do everything. Everything will be automated using the deployment component. And this deployment component will be created as a stateless component, and whenever we want to create a stateful components out of it, at that time we can use the stateful set components. And whenever we want to work with the stateful set component, it's a little bit tricky. There is a lot of extra configuration is also required, so most of them is preferred using the deployment component. But whenever you want to work with the stateful applications like database and the service registries and everything, at that time we will prefer the stateful set component. So these are all the basic components available in the Kubernetes cluster, and we are going to work with them. There are a lot of other components available, but whenever you start working on it, you will get the understanding of it and you will learn all those concepts as well. But you should know the basics of each and everything and which component is used why and where. Now let's install Kubernetes in our system for the development purposes. Now there are a lot of cloud providers that gives you the Kubernetes cluster very easily created within that cloud environment, and it is relatively very cheap as well. So if you want, you can directly use that as well. But if you want to do completely locally, so for that reason we are going to install in our local machine. So what we are going to do is we are going to install two components. One is the Kubernetes cluster itself. So for that reason we are going to install Minikube. Minikube allows us to create the local Kubernetes cluster in our local environment. It will be a one node cluster created in our local environment. And we are also going to install kubectl. You can call it as a Kubernetes controller or kubectl or whatever, but that will allow us to interact with the Kubernetes APIs. So whatever interaction that we have to do for our Kubernetes cluster, that we will do using the kubectl. So that two things we are going to install in our machine. Now if you have installed the Docker desktop, then Docker desktop allows us to create the Kubernetes cluster within that environment itself. So that also I will show you. Let me just search for kubectl install here, and we will go to the kubernetes.io website here. Okay, and here you can see that all the tools required to install the kubectl. Okay, so you can follow this and you can install in Linux, Mac OS and Windows. And here you can see that you have the option to install the Minikube as well. Now I would highly suggest you to use any of the package manager that for your operating system. So if you are using Mac, you can use the Homebrew, and with the help of Homebrew you can install Minikube and kubectl. If you're on Windows, you can use the Chocolatey package manager, and with that Chocolatey package manager you can install Minikube and kubectl. And for the Linux, the same way. All the information is available here, so you can go through it. So as I'm using Mac, let's go ahead and start with the Mac. So install kubectl on Mac OS. I will just open this here, and if you scroll down here, you will have the option to use the Intel based as well and the Apple Silicon as well. If you scroll down here, you will have the option to use the Homebrew as well. Okay, so with this brew install kubectl or brew install Kubernetes-CLI, you can install kubectl in your machine. Okay, similarly if you go to the Windows one, you can get the same information. Okay, you can using the Chocolatey as well. So if you scroll down here, okay, you can see install on Windows using Chocolatey. So with this command you can install the kubectl in your Windows as well. Similarly, you can check with the Linux environment as well. It will be different for your Ubuntu or Debian based OS based on the distributions. So make sure that you are installing kubectl and also you are installing the Minikube. So if you go ahead and click on the view Minikube get started guide, you will get the similar information that how you need to install based on the Linux, Mac or Windows. If you're on Mac, and select the platform and the Homebrew. It will be easier when you are going with the Homebrew. Otherwise, you can install the binary and do the same way as well. So with the Homebrew, you can just use the command brew install Minikube. Similarly for Windows, you can opt for the Chocolatey and you can install using the Chocolatey command. Similarly for Linux as well, you can use any of the architecture and release type and any of the package manager, and accordingly you can install. So it's very easy to install. I will show you in the Mac, and I have already created the video on the Windows that is there on the channel, but I will add that video as well in this course, so you can follow both of them. So what I will do is I will open the terminal. Let me clear everything first. So what I will do is to install the Minikube, I will use the command brew because I'm going to install using the brew. So I will just do command brew install Minikube. Okay, and I will just run it. So it will start downloading and it will update everything. Here you can see that it is already installed, so it is saying that it's already updated, but for you it will start installing. Similarly, we can go ahead with brew install kubectl. Okay, this is going to be your Kubernetes controller. So here you can see that this is also updated and the latest version is available. So this way you can see that your kubectl and minikube both are installed. Let me just clear everything, and if you run the kubectl command, you should be able to run the command, and with the minikube as well you should be able to run this command. So both are running. Now you need to start the Kubernetes server. So what you have to do is you have to check that your minikube is running or not. So with the minikube command, minikube status, you can check the status of your Kubernetes cluster. Okay, and currently you can see that my Kubernetes cluster is running. My control plane is running, host, kubelet, API server, and kube config, everything is running. Okay, so if I just use the command minikube stop, my entire minikube will stop. So my entire Kubernetes cluster will stop. Okay, you can see that powering of minikube. I will show you how to start as well. So we'll wait for this to complete. You can see that one node is stopped. Now to start, I can use minikube start command to start my minikube server. That is your Kubernetes cluster. So I will just hit, okay, my spelling is wrong, so I'll just type it correctly. Okay, minikube start, and you can see that it's starting the server for us. So you can see everything, all the steps are displayed here. So we'll wait for this to complete. Generally it will take around 30 seconds to 1 minute to create everything for you. And you can see that your kubectl is configured and everything should be running. You can see that it's done. Kubectl is now configured to use minikube. Okay, now if I clear this and I use minikube status, I should get the status that everything is running completely fine. Okay, now within this Kubernetes cluster, I can use my kubectl commands. So if I use kubectl get all, I will get all the components available. So you can see that there is one default Kubernetes service available within my Kubernetes cluster created. Okay, now if you have already installed the Docker, okay, so if you can go to Docker Hub, that is a Docker desktop install, from there as well you can create your cluster. So let me just show you that as well. Let's wait for this to open. So if you go to the settings here, okay, and within the settings, if you go to the Kubernetes, and here you can see that you can enable the Kubernetes. Okay, so with this you do not have to install the minikube. When you enable this, a Kubernetes cluster will be created when you are starting the Docker desktop. Okay, so this also you can use, and whenever you will install kubectl, it will configure to use this version of Kubernetes cluster. So that's how you'll be able to install minikube and kubectl in your local machine. I've shown you with Mac. I will also include the video of the Windows that I have created. So that's all in this video for installing minikube and kubectl in your machine. So now as we have installed the kubectl and minikube in our system, we can see different commands available in the Kubernetes. So we'll go through a bunch of commands, and with those commands we'll be able to understand how we can access the Kubernetes and how we can go through around the different Kubernetes resources and how we can manipulate them. So let's see that. What we will do is we'll start our terminal. Okay, you can see that I have started my terminal. I've switched to Windows system because this is much powerful than my Mac. So it will be able to handle all the Kubernetes cluster and the recording as well. So what we will check here is your kubectl is installed, and we will check the status of the minikube. If it's not started, we will start our minikube server. So let's check the status. We'll just do minikube status command to check the status of our minikube, that is the Kubernetes cluster. And here you can see that everything is stopped. So we need to start our minikube. So let's start it. The command is minikube start. Okay, so it will start the server. So you can see that it has started. It is restarting our cluster. We will wait for this to complete. So now we can see that our minikube has started. Okay, and now if we check the status minikube status, we should be able to get that everything is running fine. Okay, everything is configured. So let me just clear the console here, and now we can start working on our commands. So let's see the different commands in the Kubernetes. So as we know that there are different resources available, that is the pods available. That's a single unit that we can deploy to a Kubernetes cluster. Then we have replica sets, then we have deployment, then we have services, all the stuffs that we saw briefly in the previous videos. Now we will see everything with the commands, like how we can get all those information. So everything we do or we will get is using the Kubernetes controller, that is the kubectl. So this is the kubectl command, and with the get command we will get all the different resources. So if you want to get the namespaces, then we will add the, or we will give the command that is the namespace. If we want pod information, then we will give pod. If we want deployment, then we will give deployment. So this way all the different commands are there. So let's see with the pods. If we give kubectl get pods, we will get all the different pods available. So you can see that these are the different pods available running in my cluster. If you want to check with the deployment, so we can check with the deployment as well. Kubectl get deployment, and here we will get the deployments. These are the different deployments available in my cluster. If you want to check with the services, then we can check with kubectl get services to get all the services. Okay, these are all the different services available in my Kubernetes cluster. So we saw that pods is available, deployment is available, service is available. We can check with the namespace as well. So kubectl get namespaces, it will give the different namespaces. So you can see that these are the different namespaces available in the Kubernetes cluster. So these are just the basic commands to get all the resources information from the cluster. Now let's see how we can create the deployment. As we saw that deployment is a wrapper around the pods, so we can have multiple pods as well, and all the different things that we require to have for pods, like pods and the services and everything, we can wrap around each and everything in the deployment and we can deploy it. So here we will see basic example how we can deploy a deployment in our Kubernetes cluster. But before that, what we will do is we will clear it out each and everything here. So let me just do kubectl, let me just clear this first, and I will run the command that is kubectl delete all with -- all. Okay, and you can see that it will delete each and everything available in the cluster. So this is also a handy command. When you want to delete each and everything in your cluster, you can use this command. Make sure that nothing is important in your cluster. Don't try this in your production or staging environment. This is just for your local to clear it out each and everything when you are working in the local environment. Okay, so you can see that everything is clear. So I'll just use the clear command. And if you want to get all the resources at a time, then you can use the command kubectl get all. Okay, this will give you all the details available to you. So this will give you pods, deployments, replica sets, services, and everything. Okay, currently we have only one resource available, that is the default Kubernetes service. So we are getting only one detail here. Okay, let me just clear it out and let's create the deployment. So to create a deployment in Kubernetes cluster, the command is kubectl create. Everything you want to do, we can do using the create. Okay, these are the sub commands. If you want to get the help for it, you can pass -h to get the help information. You will get each and every flags available and each and every sub commands available. Okay, so with the create command, what we can create is we can create cluster role, we can create config maps, cron job, deployments, ingress job, and each and everything. So we are going to create the deployment. Okay, so let's clear it out again and let's do kubectl create deployment. DEPLOYMED. Okay, now after this we need to give the name of the deployment that we want to create. So I'm trying to deploy Nginx in our system. Okay, so for that what I will do is I will use the Nginx image available. Okay, and for that what we will do is we will give the name of the deployment as the Nginx itself. Okay, and after this I want to create the deployment. I have to pass like which particular image I want to use. So if you go to the Docker Hub, there is an Nginx image available. So I'm going to use that. So I will just define with -- image equals to Nginx. Okay, that's it. You can see that I want to create the deployment and the name of the deployment is Nginx. And for this deployment, what image I want to use? So I want to use the Nginx image. Okay, this will be available in your Docker Hub. So that's the default image I am using here. Once I run this command, it will create the deployment and it will create the pods as well alongside the deployment and a replica set as well. So let's see that. So once I run this command, you can see that we are getting deployment.apps/Nginx is created. Okay, once that is created, if I do kubectl get all, you can see that I got all the resources. I got the pod. You can see that this is the pod created, then the deployment is created and the replica set is also created. Okay, and you will be able to get all the information over here. Now if you want to get more extra information, then you can use kubectl get all -o for output and you can pass wide. Okay, so here you can see that it will give you more information. You can see that previously this was the information and now you are getting more information. You are getting the IP address, the nodes available, the nominated node, the readiness gates, and each and everything. Okay, so you will get more information. So whenever you are trying to get information, this way you can get using the -o, that is the output flag. So now let's see all the other tags. Now if you want to get the details about a particular deployment or a pod, like what's happening or what happened when the pod was created or when the deployment was created, we can get all those details using the describe command. So let's see that. We can use kubectl describe command. So with this describe command, we need to give what we need to describe. So suppose I want to describe deployment, and then after that you need to give the name of the deployment. So the name of the deployment was Nginx. Okay, so here once I run this command, you can see that I'm getting all the information about this deployment. What was the name, in which namespace this resource was created, when was created, what is the labels information. We will get to what labels is, because labels are really important part of the Kubernetes. That's how each and every resources connects together. And what is the selector, how many replicas are there. You can see that the desired are one was updated, there is total one replica and one is available. Okay, and the what was the strategy type, okay, how you want to create the different pods, that's the strategy information. And the entire pod template, you can see that which container we used. This is the Nginx image, name of the, this is the service and the image name is Nginx. Okay, and the conditions, all this information you will get from here. Okay, now if you want to get the information about the pods, we can get it similarly. So let me just clear it out and let me just do kubectl get pods to get the pod information. Okay, and I will do kubectl describe pod and I will give the name of the pod. Okay, and this will give me complete description about this pod. So you can see that it is giving me what is the name, in which namespace it is. Okay, what are the service accounts available, what is the node available, in which node it is. We'll get the node and the IP address of it, when it was created, the labels and the status of it, it's running, and the IP address. Okay, and it's controlled by what, it's controlled by the replica set. Okay, and all this information, you can see that from where the image ID is, everything. And here if you scroll down here, you will get the events as well, like what events occurred on that particular pod. So you can see that first it was scheduled, then it pulled the images, then the image was pulled, then the pod was created, and after that the pod was started. Okay, so first you can see that it was scheduled. So in the earlier architecture video we saw that there is a scheduler. So that scheduler, you can see that that's from the default scheduler, right? So that scheduler will identify like which particular pods needs to go to the which particular cluster or which node of the cluster, and all those information, scheduling and everything will be handled by it. And after that we saw the kubelet as well, right? So this is the kubelet information which will be there in the worker nodes, and it will do each and every operations according to the information by the master node on that particular worker node. Okay, so there was information about creating the deployment with the pods Nginx. So that was created using the kubelet in the worker node. Okay, so all these events and everything you will see from here using the describe command. So let me just clear it out now. Now let me just again kubectl get pods information. Now what you can also do is you can check the logs as well, right? Because whenever there is something wrong or whenever we are doing any debugging, at the time we need to see the logs, what's happening within the container or what's happening within the pods as well. So for that there is a command to check the logs as well. So the command is kubectl logs. Okay, and then after that we need to give the name of the pod. So let me just copy this and give the name, and here you can see that you are getting the complete log of that particular container running within the pod. Okay, so within this pod, what container it is running, it is running the Nginx container, and that is using the Nginx image in it. Okay, so for that you can see entire log is available here. Similarly you can get the logs for your all the different pods also available within your cluster. Now sometimes by just seeing the logs as well, the information is not enough. So sometimes you have to go inside your pod information or go inside your container, and you need to check all the relevant details, like whatever the configuration that you did is correct or not, the application should be in the correct path or not, what is the logs and everything, whatever you want to see. Okay, so for that we can go inside a pod and a container and we can execute the different commands in it. So to go inside a pod, the command is kubectl exec. This is almost the similar command that we saw in the Docker as well. Okay, so the command is kubectl exec and -it to get started with the interactive mode. And after that, what is the name of the pod that I want to check? This is the name of the pod. Okay, and after that, what command I want to run? So I want to run /bin/bash command. Okay, and here you can see that you are inside the Nginx /8F458DC5B, whatever the IDs. Okay, so you are now inside this pod information. Okay, you are now inside this pod. Now whatever the command you will execute, all this command will be within your pod. So you can see that you are getting all the information, all the directories and the files and everything. So this way, whenever you want to execute any commands within your pod and the container, you can use kubectl exec command to go inside that pod and you can execute the different commands. Now suppose we want to do any edit in our deployment. We already created the deployment with one replica set and one pod running with the Nginx server. Okay, so at any given point of time, one replica site would be there. That means one instance of the Nginx server will be running in our cluster. But if you want to do any changes in the deployment, so for that we have the edit command available. So any changes in the deployment can be directly done using the edit command. Okay, so the command is kubectl edit. Okay, and then you need to give which resource we need to edit. We need to edit deployment. Okay, and after the deployment we need to give the name of the deployment. But if you do not provide any name information, it will refer to the one instance available. Currently in our cluster we have only one deployment available, so directly it will refer to that. Okay, and if we hit enter, you can see that we got the entire deployment metadata available over here, and this is your entire deployment. Okay, so here you can see that this is the YAML file, and this is something that we are going to create in the future, that each and every resources we are going to create in our Kubernetes cluster, that is going to be using the YAML file. You can also create using the JSON file as well. YAML file is more readable, so we will go ahead with the YAML file. So here you can see that you are getting all the information like the API version used, what is the resource type, and the metadata information. Okay, and what is the specs information. Okay, specs information will define what is everything in the container. Okay, so here you can see that it is using the container as Nginx, and after that you can see that you are getting the status information as well available. Okay, like how many replicas available and what all the other status information. But now what I want to do is, currently in the specs you can see that it should be only having one replica available. Okay, so I want to change this configuration. So what I'm doing is I am just changing that I want 3 replicas. Just it is. Okay, so now my 3 instance of Nginx server should be available. So once I change any information here, just save this file and just close this file. Once you do that, you can see that the Nginx was edited, and if I do kubectl get all, you will get all the updated information. You can see that 2 new pods were created. Okay, and after that you can also see that the deployment was changed, like it needs 3 instances of available, and the replica set is also changed that it needs 3 desired state. So now you can see that we just change the information of the deployment, like rather than having only one replica we need 3 replicas, and we just change the file, we just save the file, and everything was deployed according to the configuration. We do not have to change anything. Everything will be handled by the Kubernetes cluster itself. So you can see that how easy it is to do each and everything within the Kubernetes cluster. Now you can see that all the resources and everything is created, but now we need to delete each and everything. Okay, so how we can delete? So you can see that there are a lot of different resources available. That is the replica set is there, deployment is there, then the pods is also there. Okay, but we had only created one deployment. Okay, so what we will do is, if we delete the deployment, all the relevant resources also will be deleted. So here we will just delete the deployment and everything should also get deleted. So the command to delete is kubectl delete deployment and the name of the deployment. So the name of the deployment is Nginx. Okay, once we give this, you can see that deployment.apps Nginx is deleted, and if we again check with the commands get all, you can see that nothing is available, just a default service is available. Okay, so you can see that we were able to delete each and everything, and you can see how fast it is as well to do all those operations. So these are all the basic commands that you will use in day to day while working with the Kubernetes. In the upcoming sessions, whenever there is a new command available, I will point that out, and those commands will also be used in day to day activities like creating different resources using the YAML file and deleting all the resources using the YAML file, and all those stuffs that will come in the later part. But these are all the basic things that you need to know while working with the Kubernetes. So in the next video, we will see what is the Kubernetes YAML configuration. So in this video, we are going to understand the Kubernetes YAML configuration. To understand better about the Kubernetes YAML configuration, what we are going to do is we are going to create a basic YAML configuration, and we will see different things within the Kubernetes YAML configuration and how we can create the YAML files. So here you can see that this is our project where we have the different microservice components. We have the order service with which we will be able to create the orders. We have the payment service with which we will be able to do the payments. We have the product service with which we will be able to get the products, add the products and all those information. We have the service registry component that will interact with all our different services. We have the config server which will provide the default configurations, and we have the API cloud gateway which will be the forefront of all our applications. So these are all the components available. So what we'll do is we'll just get the brief about how to create a Kubernetes YAML configuration for service registry. So we'll get the basic understanding what a YAML file should look like, and in the upcoming sessions we will create the YAML configurations for each and every components. So let me just create one folder here and I will just name it as K8s demo. Kubernetes in short is also known as K8s because starting from K and ending with S there are in between 8 characters. Okay, so that's why it's also known as K8s. So I'm just creating the K8s demo here, and within this we will create the file. So within this what we will do is we will create one deployment and we will create one service. So we will get a basic understanding about the different resources available and the YAML configuration. So for that what I will do, I will create a new file and I will define deploy.yaml. Okay, one YAML file should be created. Now all the YAML configuration will have 4 main things. That is the API version that we are going to use, like which API version we are going to use for our Kubernetes cluster. Then the next important thing is the kind, what type of resources that we are going to use. Okay, the third important thing is the specifications, like what is the specification for that particular resources, like if you are creating a deployment, what image you are using, what container you are using, is there any environment variables and all those stuffs, that all will come within this specification. And this specification section will be different based on the different resources that you use. Okay, that's for obvious because service will have the different specifications, deployment will have the different specifications, and replica sets may have different specifications. And the next is the status information. We won't be providing the status information, but the status information will be added when you create a Kubernetes resources within the cluster. So at that time whatever the status would be, that status information will be attached to that particular resource as well. Okay, so whenever we are creating we will define 3 things, that is the kind, that is the API version, and the third one is the specification. Okay, so let's start with the API version. So we'll just define API version here, and the API version for the Kubernetes cluster that I'm using is apps v1. That's the one thing. Then you can define the kind information. Okay, what is this kind? I am creating deployment, so I'll define this is a deployment. Make sure the spelling is correct and the indentation is correct because we are working with the YAML files. Okay, the third information we had to provide was the specifications. And one more thing we need to define is the metadata information for any files or any resource that we create, because we need to have some information about the resource also that we create, right? So that also we can provide. So we can define metadata. Okay, and within this metadata we can give any information. So what I will give is I will give the name here. Okay, so I'll just define this is a service registry. Okay, that's a simple name that I'm giving here. Now within this spec information we need to provide the configuration about the pods, like which particular or how the replica set should be able to select the pods for this particular deployment. Okay, so for that we need to give the configuration. So for that the configuration we will give using is the selector tags. Okay, so within the selector tags we will use the match labels tag. As I informed you earlier that everything within the Kubernetes resources works with the labels. Okay, so whatever the different labels that you define, based on those labels different resources will attach together. So the labels are really important part of the different Kubernetes resources. And within this label I will inform the app information. Okay, which app it should be. So I will just give the same information. It should be service registry. You can give any name here. So now you can see that this specification that you described, that is for the deployment. Okay, now within this you need to create a template for your pods. Okay, like within the pod what it should be. Okay, so let's define that. So here with the selector you have to define the template. Okay, and you will get all the information here. You can see that this template describes the pods that will be created. Now all this information how you will get, you need to install the Kubernetes plugin within the Visual Studio Code. Okay, now you can use any of the IDs or any of the text editor to create the YAML files. Okay, I just prefer to use Visual Studio Code, so I am using Visual Studio Code. So within this template information you need to give the template of how your pod should be. So as every resource will have the metadata information, so we'll give the metadata here as well. And within the metadata we have to provide the labels. Okay, which label that it should match it, like we described, right? Like our deployment should match the labels for the service registry here, right? So the same thing we will define, like the label should be app and the value should be service registry. Okay, so this pod whatever is created, and for that replica set whatever will be created, it will be attached with this name. Now you can see that we have to define the spec of this pod, that is the container that we are going to add. Okay, so this specification, okay, this specification is for the deployment, and this spec we are adding inside the template, that is for your pod that we are going to create. Okay, now within that what container we are going to use and the name of the container. So what I will do is I will give the same name here. Okay, and after this I can use the image. Okay, which image I want to use. So I can use daily code buffer slash service registry. So here you can see that I have just defined the name of the image that I want to use. Now in the previous tutorials of the Docker, we created the images using the zip plugin, right? So for the service registry also we had created, and those images are available within our Docker Hub registry. So the same image I'm going to use here. Okay, and after this you can define the tag information as well. So my tag information is latest, so I'm just using the latest. Whatever the version would be, you can use that version. Then you can define the image pull policy. Okay, so you can see that 3 policies are available, that is always, if not present, and never. Okay, accordingly the name itself will identify what you want to use. I'm just defining always, so every time the pod is created it will pull the images and it will create the containers on top of it. And then you can provide the ports information. Okay, so with the ports you have to define the container port, like which particular ports will be exposed by your container. My service registry will be working on port 8761, so I can define 8761 here. Okay, that I am going to expose 8761. Okay, so this is all the configuration you can see that we added for our deployment. We'll go through it again once. It's very easy. First, for each and every resources, what we will be having is we will be having the API version, the kind, the metadata information, and the spec information. After that, we will be having the status as well once we create the resources. So we just define that the API version that we are going to use is the apps/v1. If you have question like what we have to use here, you will get the information from the documentation. You can see that you will get all the information from here as well. Okay, so once you are using the Kubernetes plugin here, you will get each and everything. So the API version I am using, and the kind is deployment, because I'm going to create a deployment, and deployment will contain the pods, and the pods will contain the containers, and the containers will contain your application. Okay, so this much layer is, and pods is the basic unit or the most smaller unit of a resource that you can create within the Kubernetes cluster. So everything we are going to create is wrapped using the pod, and those pods will be wrapped around our deployment. And for every resources we will give the metadata information, like what is the names and labels and everything. So for this we define that the name of the deployment is going to be service registry, and then we added the specifications. Okay, so within the specification you can see that we added that this should select the labels which has app as service registry. So what this defines is, like whenever I'm creating the deployment will create the replica sets. So for that it should select all the pods containing the label as app service registry. Okay, that's a simple thing. Okay, anyone containing the label app service registry I should pick up and should be available for the deployment for that. Now we need to define the template of the pod. Okay, within this deployment, what is the template that we want to create. So within the template as well we want to have the metadata information, and this metadata information will have the labels as app service registry. So whatever the number of pods that we are going to create here, those number of pods will be available for this deployment. Okay, so that is service registry. Now after this metadata we define the specs of the pod. Okay, you can see that pod spec is a description of a pod. So this spec defines what it should have within the pod, and we define that we should be having a container. The name of the container should be service registry, and this container should be created with the image, that is daily code buffer slash service registry latest. And the image pull policy we define, that is always, so every time we have to pull the image and we need to create the container. And the ports we define that the ports should be exposed at 8761, because 8761 is the port that we have defined in our container. Okay, in our images. So now you can see that your deployment is created, where one file is created. Okay, now let's see another type of resource, that is the service. We will see in detail about service later, but let's see the basics of service here. So let me create a new file and I will define that svc.yaml. Service is nothing but a service on top of your pods available, right? We talked about earlier as well, like pods will be having its own IP address, and whenever there is some issue, pods will be destroyed and the new pods will be created, and for that pod new IP address will be created. So whenever we have to connect our different services, we won't be able to connect using the IP address, so we need to connect using the services. So for those reasons we create the services, and this service will be attached on top of our pods, and the IP address for this service and the host information for this service will remain constant. Okay, and the underlying pods may change anytime. So for that reason we are going to create a service, and this service will also have the same thing like the API version, the kind information, the metadata, and the spec information. So let's define API version, and here I'm just defining API version as v1. The kind I'm defining as service, and for this I have to define metadata. So in the metadata we have to define the name. Okay, so I'm defining name as service registry SVC, and then we have to define the spec of this service. So we'll define the spec, and within this spec we need to define the selector. Okay, like which particular pods I need to select here. So in the deploy as well, right, in the deployment we define the selector, right? So here also we will define in the service that it should select all the things with the app name as service registry. Okay, and this service will be exposing your ports information, right? So we need to define the ports here, and this may contain multiple ports, so we'll define the port information, like what should be the port of this service. So I'm defining that its port should be 80, that is the default HTTP port. Okay, so this service in any of the node will work with the port 80. Okay, that is the target port. Okay, like what we are targeting. So here we have defined that port is 8761 that we are exposing from the container. So this is the port that we are targeting. So we will define that target port is 8761. Okay, so you can see that this service will be running on port 80 and it's targeting the port 8761. So what it will do is it will select the applications running with service registry as the name. Okay, all those services will have the 8761 port as exposed, and those will be used to connect to this service, and this service will be running on port 80. Okay, that's the simple thing it's doing. Okay, so you can see that we have the deployment file created. Okay, we have defined each and everything YAML configuration, and for the service as well we have defined each and everything with the YAML configuration. Okay, now let's see how we can deploy this in our Kubernetes cluster. So I will go to the terminal here. Okay, and I will go to this directory. I'll go to the F directory here, cd daily code buffer, github, spring boot microservices. Okay, and here you can see that within this I have the K8s demo. Okay, so let me go to K8s demo. Let me clear it out. So here you can see that we have two files available, that is deploy.yaml and svc.yaml. Okay, and if I see kubectl get all, we do not have any resources available. Okay, and now let's see how we can use this. So we can use kubectl apply command to apply the configurations. Okay, you can see that these are the configurations for the different resources. So we have to use apply command to add all the things, and with -f command we need to give the file information. So with -f I am giving deploy command, deploy YAML file. Okay, so with kubectl apply command, that is apply my configuration, with -f that is the file that we have, that is the deploy.yaml. Okay, once I run this command you can see that service registry is created. Now if I run the another command, that is the kubectl apply -f service.yaml file. So for this also you can see that the service is created. Okay, if I clear it out and I do kubectl get all, you can see that your pod is created using the deployment file. So you can see that the services are created, right? We have the Kubernetes service that was the default service, and this is the service registry SVC that we created, and we have the deployment created, that is service registry, and we also have the replica set created. So you can see that all those information are created based on the YAML configuration that we have provided. Okay, so you can see that we just defined two YAML configuration files. Like in the YAML configuration we just defined like what we need, like we need to have the deployment. That deployment should be having a name, and within that deployment what container I want to use, like what pod information. So we define the template for the pod, and within that pod we define, okay, I want this container with the name this, and within that container should be created using this particular image, and these are the pods that I need to expose. So all those information I gave here. Okay, so you can see that it's a really simple file. Okay, and these are the only things that we are going to create. And the similar thing we did for the service as well, like I define that API version, the kind information, metadata information, these specifications and everything, and we define the port information as well, and accordingly I applied all the changes, and all the details are available here. Now if I want to delete each and everything, I can do using the delete command. So I'll just define kubectl delete command, and what I want to delete, I want to delete all the resources mentioned in the deploy.yaml file. Similarly, I want to delete all the configuration mentioned in the svc.yaml file. Okay, you can see that everything is deleted. Now if I see kubectl get all, you can see that nothing is available, everything is deleted. So you can see that how easy it was to create the YAML configuration for our Kubernetes resources to be deployed in our Kubernetes cluster, and how we can apply all those changes, how we can remove all those changes as well very easily. So this was all about how we can create the different resources in our Kubernetes cluster using the YAML configuration. We will see a lot more in detail about the different YAML configurations, the environment variables and everything in the later part, where we are actually building all these different resources for our application that we have created. Okay, this is just a basic to get you started. Now in the next video we will understand about the Kubernetes namespaces. Now let's talk about Kubernetes namespaces. Now Kubernetes namespaces are just a virtual clusters inside a Kubernetes cluster. So if you have a Kubernetes cluster, and if you want to divide that Kubernetes cluster into different small clusters that you can use, or that you can achieve using the Kubernetes namespaces. There are a lot of advantages of using Kubernetes namespaces, and there are different namespaces also available by default. So let's understand about the Kubernetes namespace. So by default, Kubernetes comes with the default namespace where you can deploy all your resources. Okay, so by default, if you can see here, whatever the resources or whatever the deployments, applications and whatever you deploy in the Kubernetes cluster, when you're not defining the namespace, everything goes into the default namespace. Okay, so you can see that this is how it looks like within the Kubernetes cluster, within the default namespace, like different applications installed. But if you use different namespaces for the different things, okay, and you try to manage each and every resources, it looks a lot cleaner as well. So suppose if you see here that you have different applications deployed in the different namespaces for your different types of components, with that you will be able to handle your resources much better, and you will be able to handle your resources in a much better way. So here you can see that you can create different types of namespaces. Okay, and within those namespaces you can deploy the different components available. So let me just show you how to create the namespace. So if we go to our terminal, okay, and if you want to create the namespace, the command is kubectl create namespace, and then you need to give the name of your namespace. So suppose I'm giving my namespace. Okay, so this will create a namespace within the Kubernetes cluster with the name my namespace. Okay, you can see that the my namespace is created. Now if you want to see the namespace, you can check using the kubectl get namespace. Okay, here you can see that your my namespace is created 15 seconds ago. This is what we created. Okay, and by default Kubernetes comes with the 4 default namespace, that is the default kubnode lease, kubepublic and kubesystem. This Kubernetes dashboard namespace is a different namespace, comes with the Kubernetes dashboard. We will see that as well, like how to create the Kubernetes dashboard. But these are the 4 namespace that comes by default, and this is the namespace that we have created. So let's see about this namespace. So by default there is a default namespace available, and this default namespace is for all the resources that you create. Okay, so whatever you are creating, like deployments, pods, services, replica sets, everything will go towards the default namespace if you are not defining a specific namespace. Okay, so for all those resources, default namespace is used. The another namespace is kubesystem. Kubesystem is reserved for all the resources for the Kubernetes system, like your API server, your control manager, your scheduler, your Kubernetes proxy. All those are within the kubesystem. It is advisable that we should never use the kubesystem as the namespace to create any of the resources. We should always create a new namespace, and within those namespace we should create our resources. The third namespace is kubepublic. This kubepublic namespace is for the public access, so all the information related to the Kubernetes cluster and everything will be getting from this particular Kubernetes namespace. So all the information we will get from here. And the next namespace is the KubeNode lease namespace. So KubeNode lease namespace is to create or to get the lease object from the Kubernetes cluster. So suppose if you have the pods created, and for that pods, if you have to have the heartbeat information, like just for the health check information, that you can have those lease from the KubeNode lease, and all those information will be stored within the KubeNode lease namespace. So these are all the 4 basic namespaces available by default. We just need to be aware about this. By default, if we are creating any resources, everything will go towards the default namespace. And if you want, we can always create a new namespace, and within that namespace we can define our resources. Now let's see how ideally we should use the namespaces. Okay, so suppose if you have multiple teams available, right? Suppose we have the project A, B, C and project XYZ. So both the teams are working on the different application, but the Kubernetes custom for your organization is same. So how we should restrict all those resources within one team and restrict other resources within the other team. So for that, the namespace can be created, and within those namespaces, all the resources can be created. So suppose within my ABC team, I can create the deployments and everything using this particular namespace itself, where we can define like whatever the resources are created should be created within this namespace. For the project XYZ, we can tell all the resources should be created in the XYZ only. So that way we can bifurcate all the resources using the namespace. Suppose if you want to bifurcate using the environment, that way also we can do, like all these resources within the cluster should go to the dev namespace. If you have a staging environment, all these things should go to the staging namespace. That way also we can do all the different applications and services. Okay, this way also we can do the bifurcations. Now let's see how we can deploy the resources in the Kubernetes in a particular namespace. So we already have a namespace created, that is the my namespace, right? And we already have the Kubernetes YAML configuration that is created. So let's try to deploy this particular components within the my namespace. What I will do is I will define the same apply configuration, that is the kubectl apply -f ./deploy.yaml. By default, it will create each and everything in the default namespace. But if I want a particular namespace, I can define it using the -n. Okay, and then I need to give the name. So my name is my namespace. Okay, this is the name of the namespace. Now if I apply all these changes, okay, you can see that all the things are created. And if I do with kubectl get all, you can see that you are not getting all the information. Okay, because by default kubectl get all will give you the information from the default namespace. But if you provide with -n my namespace, you can see that you are getting each and everything. So you can see that the other resources will not be visible to the different namespaces as well. So all the resources that we created are within the my namespace only, and we are able to see. Now there are different types of components, and those components can be within the namespace. So those components will be bound to the namespace, and there will be some components which will be not bound to the namespace. Okay, so I will add the link in the description for you to check like which resources are available for or within the namespace and which resources are not available within the namespace, that you can create throughout the cluster, throughout all the namespaces. Okay, so this way we can work with the namespaces. We can create the different namespaces according to the requirement. You can have any of the workflows created, like based on the different teams, based on the different environments accordingly, and we can create the resources accordingly. So this will be a much neater way to create the different resources in the Kubernetes cluster. So now let's talk about the different services available. So within this Kubernetes cluster, we have the different services available. But first understand why we need a services. So suppose if we have the multiple applications, right? And for all those multiple applications, we might have created the different pods available. So currently you can see that we have app 1, app 2 and app 3. And for all those applications, we have the different pods available. That is multiple pods, like app 1 has 3, app 2 has 3 and app 3 has 3. Okay, and as the pods have the ephemeral life cycle, that means whenever there is an issue with the pod, that pod will die and a new pod will be created, and for that new pod, new IP address will be created, right? So suppose a new IP address is created and a new pod, and if that particular application 1 has to connect to the application 3, then there is a constant configuration change, right? So a new IP address has to be connected to the new IP address, and that is not a good case, right? So what services provide us to have a one service attached to all the different pods that we have, right? So suppose we have created the 3 different services, that is the SVC F1, SVC F2 and SVC F3, and all those services connects to their pods for that particular application. Now how they will connect to this pods, like service 1 will connect to this pods only, service 2 will connect to this pods only, and service 3 will connect to this pods only. Those will be happening based on the selectors that we define in the YAML configuration. Those selectors will be defined based on the labels that we created, right? We saw earlier in the configuration as well, like that we will be creating the labels, and based on those labels the resources will attach together. So this services will be having a label, like it should select the labels, and those labels will be having the details of these pods. Okay, so that way this all pods will connect to this service, this all pods will connect to this service, and accordingly. Now whenever any pod dies and a new pod is created, that pod will be also assigned to this service. Okay, so now behind this service, whatever the pods are created, we do not have to worry about the pods, their IP address and all those information. We can directly have the access to the service, and this service can talk to the different services available, right? So it doesn't have to directly go and connect to the different pods, right? Because based on the pods life cycle, it can delete and recreate with the new IP always. But for the services, we will be having the same IP address, okay, and the same host information, so they can connect directly. What it can do is service 1 can go ahead and connect to service 3 based on the services that we have defined. Similarly, service 1 can go ahead and connect to the service 2 based on the services that we have defined. Similarly with service 2 to service 3 as well. So you can see that all the pods will have the services in front of it, and those services will interact with each other in the Kubernetes cluster. So that's the importance of service, and for these services we have the different types of services available. So basically we have 4 services available, divided into 2 categories, that is the internal service and the external service. In the internal service we will be getting the cluster IP service and the headless service, and in the external we will be having the node port service and the load balancer service. Internal service means those services will be created that will talk internal to the cluster itself, and the external service will be created that can talk outside the cluster as well. So let's start with the internal service, that is the cluster IP first. So in the previous example also we saw that we had created the deployment, and for that deployment we had created the service. Okay, so here you can see that this is the sample that I'm showing you, that we have created a user service app, and this user service app has the different information, and we have created the service also for this information. Now this particular service will connect to this deployment based on the selector that we have defined. Okay, so you can see that deployment has the label, that is the app user service app, and the service has the selector as app user service app. So based on this connection, both will connect. Okay, so this deployment will have the service in front of it, and alongside that we need to match the port information as well. So the deployment has the ports exposed in the container is 9002, and in the service where we have defined as my service should be running on port 80, and the target port it should go and connect to is 9002. So that way our service will assign to a particular pod, and the target port will also be assigned to the container pod that we have mentioned. So this way a cluster IP service and the deployment or the pods will attach together, and it will serve the request. The next is the headless services. So when we need the headless services, so whenever we are working with the stateful sets, at that time we will need the headless service. So stateful sets we create for our sticky identity. So whenever you need a sticky identity, at that time we will be using the headless service, and the headless service will be created as this way. Like in the specification we will define that this is a cluster IP as none. That means this is not a cluster IP as well, and we have not defined any type as well. So that means this is be a headless service, and the headless service will connect to stateful set using the name itself, like using the metadata. So you can see that with metadata name Eureka and the service name is Eureka, they will connect and they will serve the request. Now whenever we will be creating the stateful sets, it will be like Eureka -0, Eureka -1. We will see about the stateful set in the later videos, but this is just the basic. We will just need to understand the headless service here. Okay, so this is also one type where we can create the headless service using the cluster IP as none described. The next one is the node port service. Now the node port service is the external service that you can create, and you can see that you have to define this spec type as node port. Okay, once we define this node port, it will create a node port service, and for this node port service we have the port range defined. So you can only use the port from 30,000 to 32,767 port information only to create this node port, and the node port service will be exposed based on the nodes that we have. So within the cluster, different nodes will be available. So for each and every nodes, that port will be exposed within the cluster using the node port service. The next is the load balancer service. As the name itself suggests, that it's going to create a load balancer for your entire Kubernetes cluster. So only one port will be created for your entire Kubernetes cluster. Only one port will be exposed, and based on that port opened, it will take all the requests from the external world and it will traverse all the traffics to the respective services that we have. Okay, so this way we can define the load balancer service as well. It will be exposed for a cluster and the node port will be exposed per nodes in the cluster. Okay, so it is always advisable to not use node port services, always use the load balancer service. So these are all the basics about the different services that we have in the Kubernetes cluster. So we will be creating this type of services later in the configuration files when we are working with our application, where we will create the configurations for those applications. Okay, so this is just the basic about services. We should know like which type of services that we get from the Kubernetes cluster, or how we can, or which type of resources that we can create. In the next video, we will be talking about the Ingress services. Now let's talk about the Ingress service in the Kubernetes cluster. Here you can see that within the Kubernetes cluster, we have defined that there is one app available, and for that app, there is a service available. Now how ideally we talk to these services? We talk using the IP address that we have, and we have the port information. That's how generally the services will be exposed, and that's how we will be able to access those services within the Kubernetes cluster, because directly the external traffic is not allowed within the Kubernetes cluster. So we forward those port information, and those IP address we will get, and those IP address we will use to access those information or access those services in the Kubernetes cluster. But in the ideal world, we do not call all our applications using the IP address. We call them using our DNS name, right? Suppose here you can see that we have a DCB app. For that we have a DCB pod and the service, but rather than calling all those services using the IP address, we call them using the domain name that we have, like suppose dcbapp.com, dcbapp.in, or whatever it is, right? So that's how we call those services when the external traffic is coming to your Kubernetes cluster. So to handle all those things, we have the Ingress component. So we can create the Ingress component within the Kubernetes cluster, Ingress services, and Ingress services will understand all those requests coming from the external world based on the DNS, and it will route all the traffic to the respective services that we have created within the Kubernetes cluster. So for that reason, we have the Ingress services in the Kubernetes cluster. So like all the other resources, we can create the Ingress component using the YAML configuration. We can define the kind as Ingress and the metadata information, and we can define the host information. In the specifications, we have to define the host information, and within those host information, we have to define the different paths. Like when we get this path, we should route this particular request to which services accordingly. These services will be your cluster IP services that is internal to your Kubernetes cluster. So with this YAML configuration, we can define this Ingress components in our Kubernetes cluster. And for the host that we have provided, right? So for that host information, we need to provide the entry point IP address as well. So we need to configure those IP address such a way that that IP address belongs to the one of the nodes in the Kubernetes cluster, because from that only we will be able to understand that this request should come to this Kubernetes cluster and your request should be handled internally, right? So that way we have to configure our DCB app, that is our DNS name, in such a way that it points to the node of the Kubernetes cluster, and from there we have the different services available, and all those traffics will be routed to the different services. Now all this information, you can see that it is traversing the traffic and each and everything. Ingress component, right, is doing that, all those things. So how Ingress component will be able to do this, right? So Ingress component or Ingress service will also have a Ingress controller. This Ingress controller will be able to handle all these requests. It will able to handle, okay, I am getting requests from this service and it should be routed back to this services. So by default, these are the different Ingress controller available, and any of the Ingress controller we can use to create our Ingress services. So what we have to do is we have to add this Ingress controller in our Kubernetes cluster, and according to that our Ingress service will work. So you can see that this is the entire list available. I will also add the link in the description for you to check the different Ingress controllers available. But Ingress controller will handle each and everything for our Ingress service that we create. Now all the cloud providers that we use, right? All those cloud providers by default gives us the load balancer. Those load balancer will be able to handle all our traffic, so that will have the Ingress controller for us, and we can directly create the Ingress services to handle the traffics accordingly. Okay, so we do not have to create or install any new components when we are working with the cloud as well. But if you want to do within your local system, then with the Minikube add-ons list, you can see the different add-ons available, and you can see that there is a Ingress component available, right? So this particular Ingress component by default, it will be disabled, so we need to add it. So you can add using the Minikube add-ons enable Ingress command. Once you add this, or once you run this commands, this will be enabled. You can see that the Ingress component is enabled, and now with this Ingress component you can create the Ingress services in your local environment, and you can run all your services in the local environment. But by default, whenever we are working with the cloud environment, by default we have the load balancers available, and those load balancers are configured in a way to handle the Ingress traffic. So we do not have to add any add-ons there. We just need to configure our Ingress services. So this is all the basics about the Ingress services. You just need to know about how the Ingress service works and what is the Ingress service and how it can be created. Now in the next video, we will talk about the stateful sets in the Kubernetes cluster. Now stateful set is similar to what we had seen in the deployment. It is also a wrapper around the pods and the different resources, but the only key difference between the deployment and the stateful set is stateful set will work with the stateful applications. So suppose if we take the example of the MySQL database, MongoDB, Oracle, Cassandra, right? This all stores the data. So all this data will store the state of the application. So whichever the application stores the state, for that we will be using the stateful sets. So to understand more on the difference, let's take one example. Let's take the example of a Java application, and for that Java application we have the MySQL as a stateful application that will store the data. Okay, so whenever the request will come from the browser to your application, okay, it will contain some of the data. So suppose in our application it is containing the JSON data, that it will pass the data, and that data from the Java application will be processed and it will move that data to the MySQL database. Okay, and vice versa. So whenever we want any data, we will be querying those data. So your application, your Java application, which you are going to deploy, will be a stateless application. Okay, it is not storing any state of any information. It is just processing your data. All the state information is being stored by your MySQL database. So your MySQL database is your stateful application. Okay, your Java is just getting the data, it's processing. As you can see that we got the JSON data, and it's passing the data back to your MySQL. And whenever your application needs any data, it can query the data, and MySQL will send the data accordingly. So this is the difference, where your Java application would be your stateless application, and your MySQL where you are going to store the data, that is going to be your stateful application. And for the stateful application, we use stateful sets. So let's see the difference between a deployment and a stateful set, so we will get a better understanding about when we need a stateful set and when we want a deployment. So let's start with the deployment first, like when we need the deployment. So taking the example of a Java application, you can see that in Java application also we have one pod, and in MySQL also we have one pod available. Okay, but when we scale the application, right, in the Java, you can see that I have instantiated multiple pods available, and for each and every pods, when the new pod is created, the pod name would be like the name of the pod or the name of the deployment that we create, hyphen, there will be a hash value generated, and this hash value will be completely random. So whenever a pod is died, right, and a new pod is created, it will be having a new hash value. So every time the hash value will always be different. And for that, what we do is, to make sure that all the applications are able to connect to these pods, we create a service, and this service will connect to each and every pod that we have. And when the load balancing will happen, it will be based on the different load balancing scenarios, and we will not be able to make sure that which request will go to which node. Whichever nodes are available, the request will be served to that particular nodes. Now let's take the example of the MySQL. In MySQL, when we scale up the application, and when we scale the application, what we need is, we need to scale our stateful applications. Scaling a stateless application is really easy, but scaling a stateful application is really difficult, because we need to take care about the data consistency as well. So here, when we create a stateful application, you can see that it will create the pods based on the identity. So it will have a sticky identity. In the stateless application, that is the deployment, when we create a deployment, a hash value is generated for the pod. But when we create the stateful application, a unique ID will be created starting with the 0 index, and accordingly it will increment the value and the pod value will be assigned to that accordingly. Let's deep dive into this, because when we are working with the stateful applications, the most important thing is the data consistency. Okay, so ideally what we do is we create one node. That node is for our read and write operation, and we have the other nodes available that will be supporting your read operations. Okay, so currently if you see that I have MySQL 0 as a master node, and the other we have as a slave or a worker nodes available, okay, for your MySQL. So your application is designed in such a way that your MySQL 0 node would be for your read and write operation, and MySQL 1, 2 and whatever the number comes, that would be for your only read operations. Okay, accordingly your application will work. So what you would have defined in your configuration, like always go to MySQL 0 pod, that is the container for my read write operation. Okay, so that we have defined as a read write operation here, and for MySQL 1 and 2 we have just defined the read operations. Now whenever we do the scaling operation, what will happen is whatever the last state of the application that we have, right? Suppose the last was created was MySQL 2, and based on the MySQL 2, the MySQL 3 would be created. So whatever the previous state would be, that previous state would be used to create the MySQL 3 here. So this way the new node will be created based on the previous node that we have already created. Whatever the state would be, based on that state a new node will be created. And when we try to delete as well, when we try to downscale, the last node which was created, this was MySQL 3, this will be deleted, and then MySQL 2 will be deleted, then MySQL 1 will be deleted, and so on. Okay, so you can see that with stateful set it will be having a sticky identity, and a sequential flow would be there for scaling up and scaling down. It won't be random as what we saw in the deployments. One more thing to note over here is, like whatever the operations that we talked about here, right, like the replications and scaling up and creating the snapshots and everything, right, when we have read write operations, so all those scalings and everything has to be handled by the user itself, like by MySQL. So all the configuration we have to provide. Kubernetes does not provide any configuration to handle all such cases. Mainly Kubernetes suggests that we should use stateless application to be deployed in the Kubernetes cluster. But if we want to do stateful application as well, Kubernetes supports that all the configuration has to be provided by a user, like how your replication should be handled, how your data consistency should be handled, and all those configuration for a particular stateful application that we use, like MySQL, Oracle, Cassandra or anything. We have to provide those. Kubernetes will just support each and everything. It won't provide you by default configuration for that. So these are the differences between the stateful sets and the deployment. We are going to use both deployment and stateful sets for our application, because in our application we had used the MySQL. So for this MySQL we are going to create a stateful set, and with that stateful set we are going to create our applications. So we'll get to know in detail about how to create the stateful sets, deployments and everything, but this was just a gist about what is the difference between the deployment and stateful set and when to use which one. So that's all about the stateful sets in Kubernetes. In the next video we will see about the volumes in Kubernetes cluster. Now whenever we are creating the applications, for those applications we use any database, and those database will be a stateful applications, right, because it is going to store the state of your application. It is going to store the data, and based on the pod lifecycle that we have understood till now, that whenever there is an issue with the pod, that pod is entirely destroyed and a new pod is created and it will assign a new IP address. So if there is an issue in the pod and if that pod is destroyed, we might lose our entire data altogether, right? So we must not lose any data that we have stored, right? So for that purpose, volumes comes into picture. Volumes are nothing but your storage providers, where you can use any kind of storage that is outside your cluster, and that storage you can use in your Kubernetes cluster to store any data. So you create a pod, in that pod you have your stateful application like MySQL, Oracle or anything, but the backend storage which it use to store all the data, to back all your file system and everything, will be outside your Kubernetes cluster. It might be your local system, it might be your on-premise, it might be your cloud provider as well, whatever it would be, but it would be outside your cluster, and with that you will be able to access each and everything. You can create inside the cluster as well, but the backend storage which it use to store all the data, to back all your file system and everything, will be outside your Kubernetes cluster. And with that you will be able to access each and everything. You can create inside the cluster as well, but but it is not recommended. It is always best practice to use anything outside your cluster, so you would be able to use it. So this is what the volumes will be used for. Now there are important things that we need to consider when we are using a storage for our Kubernetes cluster. We need to make sure that storage should not be dependent on the pod lifecycle. So your pod lifecycle is like whenever there is an issue, pod will be deleted, right? But your storage should remain the same. It should not be dependent on the pod lifecycle. So make sure that we create a storage in such a way that it is always available, and whenever a new pod is created, that pod can use that storage which is already available. Okay, storage should be available to all the nodes available. We should not be like, okay, this storage is only available to one pod or anything. It should be accessible throughout all the nodes in the Kubernetes cluster. So wherever the pod is created, right, those pods will be able to access your storage. Storage should survive cluster crashes as well. So whenever there is any issue with your entire Kubernetes cluster, your storage should be intact. So that's why it is recommended to have your storage outside your Kubernetes cluster, and that storage you can use as a volume in your Kubernetes cluster to access that storage. Your volumes are just similar to all the other resources that you have, like RAM, memory, CPU, and that way it would be a persistent volume. So persistent volume is something that we are going to create in a Kubernetes cluster to access a storage outside a cluster. So the persistent volume is also created using a YAML configuration file. You can see that we are going to create a persistent volume as a kind information. We are going to give the API version and the metadata information. And within this specification, we can define the specs of that particular volume. Like you can see that which is the host path information available, how we are going to access this storage, and what is the capacity, and what is the storage class name. You can see that all the details we have defined as a YAML configuration, and we can apply this configuration to your Kubernetes cluster to get those resources ready for you. And you can see that these are the different providers available. So with all these providers, you can access your storage, and those storage, whatever the storage is created within those providers, you can add all those as a persistent volume in your Kubernetes cluster. Now whenever we are going to use the persistent volume, you can see that persistent volume is created in your Kubernetes cluster, and this volume you have to use in your pod in any of the namespace. Okay, so within this pod, what you have to do is you have to claim that particular persistent volume as well. Like this is the persistent volume that I want to use. Once you claim it, you will be able to add in your pod, and you will be able to access that. Okay, so for that we have to create a persistent volume claim as well. That is also known as PVC. That also we can create using the YAML configuration. So you can see that this is the YAML configuration where we have defined the API version, the kind information as persistent volume claim. The metadata that we gave is the name of the persistent volume claim, and the specification that we define. We define that what is the storage class name, the access modes, and the resources. You can see that these are the different persistent volumes available, and this claim is trying to get a 3 GB version of it. You can see that we will get this 3 GB assigned to this particular persistent volume claim. Once we claim this, we will be able to access in our pods. So you can see that here we have defined that persistent volume claim and the pod as well, and this task PV claim, that is the persistent volume claim, we have added as a volume in our pod information, in this specs information, where we have defined that this is the volume that we are going to use, and this is the persistent volume claim, and this is the claim name. Okay, and here we can see that once we define the volumes here, we can add as a volume mounts in our container. So this is how you will be able to create a persistent volume claim and a persistent volume in your Kubernetes cluster. Now who creates persistent volume and who creates persistent volume claim? Ideally your admin team, your resource providers will be creating the persistent volumes for you. Suppose if you're working in any one of the project and you have the admin team or the infra team and you need 10 GB of storage to be used as a storage in your application. So what you can do is you can request them, okay, any 10 GB of storage of this kind, please create a persistent volume for us. They can create a persistent volume for you, and you can use that persistent volume using a persistent volume claim into your resources. So that's how generally it would work. So it will be always a request that you will create manually, like, okay, this is something that we need, and you will be claiming that and you will be using it. But what if you need something dynamically? Right? So storage class is a way that you can provision persistent volumes dynamically, and this will be always like when persistent volume claims in. So suppose I want 10 GB of storage, and what I will do is I will create a persistent volume claim with a storage class. So what it will do is, if the resource is available or not, it will dynamically create for us and it will assign to me. So that's why a storage class is used in the production applications. So you can see that these are the different ways that you can create the storage class. You can see that we have defined the storage class, and these are the providers. You can see that Google also provides and AWS also provides. Okay, and we can configure everything like how we need. And similar to other resources, we will be able to create each and everything using the YAML configurations. So you can see that these are the different storage class providers. We can use any of them based on our requirements. So this was all about the basic information about the volumes, persistent volumes, volume claims, and storage class in Kubernetes. So we are going to use this in our application when we are building the Kubernetes resource files for our entire microservices. Now, health checks are really important part of any of the application, and Kubernetes also provides a way to check the health of our applications using the probes. You can see that. So it allows us a liveness probe, readiness probe, and a startup probes. So let's talk about that. So what's a liveness probe? So liveness probe defines that is your application live or not? Is your application healthy or not to process your request or process the client's request? So that is what a liveness probe defines. Your readiness probe is defined by is your application ready to serve the request or not. Suppose when you are starting your application, sometimes your application is dependent on the other third-party applications as well. So your application is only be able to serve the traffic once your all the dependent applications and a current application is completely started. Once that is started, once everything is done, then only you can say that your application is ready to serve the traffic. Okay, so that is what a readiness probe defines. So we can configure a liveness probe and a readiness probe in our Kubernetes cluster for each and every pods that we create in a Kubernetes cluster using this two probes. And all these probes, that is the liveness probe and the readiness probe, can be defined using the different ways. We can define using the HTTP request, we can define using the TCP, we can define using the commands, and we can also define using the gRPC request. It is in the beta for now, but yeah, in the future it will be available to do the gRPC request to check the health of the application. So let's check the basic example like what we can do here. So this is a normal YAML configuration file. Okay, here you can see that we have the API version, the pod information, like this is going to be a pod, and it has the metadata information. Okay, it has a name, labels, and everything, and it has a spec information. So here you can see it defines, it's having the containers, the container name is this, the image is using the busybox, and different arguments. Okay, so this is all the configuration about the pods. Now you can see this is a liveness probe. This defines that your application is live or not. So always you need to check that my application is running or not, my application is running or not, is it healthy or not. All this you need to do. So for that you can see that first method used is the command execution. So you can use any command to check the health of your application. So here you can see the command is used is cat/temp/healthy. So this is what something used. And then the attributes are used as initial delay seconds. So after how much time this should start checking the liveness probe, and at what interval you should check the liveness. So you can see that 5 is defined. So every 5 seconds it will check the health of your application. So this way you can define the health check with liveness probe in your Kubernetes cluster. Similarly, you can see that this is defined a liveness with the HTTP request. So you can see this is a liveness probe with HTTP get. Earlier we saw with the command execute. So this is with the HTTP get, and here we have defined the path, like it will call this path on this port, and the headers will be this, and the initial delay seconds means 3 and period seconds is 3. So every 3 seconds it will try to check on this particular health endpoint. Similarly, we can do with the TCP as well. So it will check for the TCP connection. You can see that here we have defined with the readiness probe. So it will check the TCP socket on the port information defined. And you can see that liveness probe is also defined with the TCP socket information. So this way, both the probes can be defined. It's very easy to implement. We are going to implement in our application as well. And similarly, you can see that we have defined for the gRPC as well. So if you have the gRPC request, you can define the gRPC as well on what port information you need to check, and the initial delay seconds and the other field. So these are all the basics about the health checks in Kubernetes cluster. You can see that we have just gone through the documentation here, but this is something that we are going to implement. So I just want you to understand what is the difference between the liveness probe, readiness probe, and the startup probe. We are going to use the readiness and liveness probe because startup probe is something that is being used in the legacy applications generally, because legacy application takes a lot of time in starting. So for that, a startup probe is defined. But Here we are going to use the liveness probe and the readiness probe. Now you can see that all the basics are covered. We have gone through all the different resources available in the Kubernetes cluster. We have also gone through the different commands available. So we saw the different commands, we saw how to create the YAML configurations, and we also saw how to apply those configurations in the Kubernetes cluster. So till this point, we are aware about all the different resources and how we can work with the Kubernetes. Now let's go ahead and implement the different Kubernetes configuration for our microservices that we have. So now before implementing the Kubernetes configurations for our application, let's first go through the basics here. We have this many applications available, that is the Cloud Gateway, Config Server, Order Service, Payment Service, Product Service and Service Registry. Okay, these are the applications that we have. So these all applications we have. Alongside all these applications, we have other components as well. We are going to use the MySQL, right? So for the MySQL also, we need to have the configurations. We are also using the Zipkin and Sleuth. So to install Zipkin also, we need to have the configuration. And we are also using the rate limiter. So for that rate limiter, we are going to use the Redis. So for the Redis also, we need to have the configurations available. So these are the things that we will need to have the configurations. Now let's get the basics clear. Out of all this, we are going to create a deployment for each and everything. Deployment will be nothing but a pod created for your application, and for that pod you will be having one service. So all the pods wrapped around in a deployment and a service for that we will be creating. So for the Cloud Gateway, we will create a deployment. That deployment is nothing but a wrapper on top of your pod. That pod will be having the image out of it. We had already created the images for each and everything, but we will create it from here. And for the config server also, we are going to create a deployment. For the order service also, we are going to create a deployment. Same way for the payment service and the product service. But for the service registry, we are going to create a stateful set, because service registry will be storing the state, or it will be having a state of each and every application that connects to it. Right? Because what we need is, we need to have this service registry available at any given point of time. Everything should connect to that particular service registry, and all the services will connect to that service registry using the DNS name. Okay, so for that reason, we are going to create a stateful set rather than the deployment for the service registry, as it is storing the state of the entire app microservices, all the different microservices. Then comes the MySQL. MySQL is also going to store the state of each and everything, right? Because it is going to store the data. It's your database. So for that, MySQL also we are going to deploy using the stateful sets. Zipkin and Redis will also store the logs and the rate limiter information, but for those we are going to use the deployment for now, just to make it simple. We do not want to create each and everything with the stateful sets. So this is the plan that we are going to create, and for each and everything we are going to create a different configuration files, and we are going to deploy each and everything in our local environment. And later in the tutorial, what we are going to do is, we are going to remove the complete service registry part as well. Currently we are using service registry, but Kubernetes also provides us the service registry. So we are going to leverage that service registry also. So when we are leveraging the Kubernetes service registry, we do not require our own implementation of the service registry. So all this configuration we are going to do, and we are going to deploy each and everything in the Kubernetes cluster. So it is going to be a really fun in this video. So let's start working on it. So now let's first prep up everything. What we will do is, I will create one folder here, and I will name it as K8s. Okay. So this is going to be my folder where I am going to create all the Kubernetes files. The other thing that you can do is, if you are using the Visual Studio Code, then you can go to extensions and you can search for Kubernetes, and you can install this Kubernetes. Then you will be able to use the different snippets to generate our code. We do not have to write each and every line. We can generate each and everything by default. We're using the Kubernetes plugin. So make sure that you install this Kubernetes plugin. Once you install the Kubernetes plugin and you have created the K8s folder, and we will make sure that at this point we have all the images ready in our Docker Hub. So what we will do is, we will just open the terminal here. Okay, run the command to make sure that a image is created in the Docker Hub. So what we will do is, I will go inside the Cloud Gateway, and I will run mvn clean install gib::build command. Okay, this will create the image for my Cloud Gateway, and it will publish to my Docker Hub. So let's run this, and we will wait for it to complete. And we are going to do this for each and every application. So you can see that it is pushing the images, and you can see that build is successful and the image is pushed. The cloud gateway is done. Let's do for the config server. We'll run the same command, that is the mvn clean install zip:build. So this is just the prep work. If you have not done in the past section, make sure that you do it, because we are going to use all these images to deploy all the things in our Kubernetes cluster. So you can see that it is now pushing the images. You can see that your config server is also done. Now let's do for the order service. Mvn clean install zip:build. Okay, you can see that this is also completed. So you get the gist, right? Like you need to do this, or you need to publish each and every images to the Docker hub, because from there only we will be able to use. Now with this, we also need to make sure that whatever the environment variables that we have defined, like whatever the configuration that we have defined, we need to make sure that those configuration we can pass along via Kubernetes configuration as well. Okay, we should not be hard coding anything. There should be an option to pass the configuration from outside as well. So let's check all those information as well. So within the cloud gateway, if we go to the src main resources and the application.yaml file, let me just close it out. And you can see that we have a way here. We have defined the config server URL. So this is something that we can pass from outside. But here you can see we have defined such a way that we can either pass localhost or the host information. We cannot pass the entire URL, right? But when we are working with the Kubernetes, we do not need to have the port information as well. We can directly access each and everything using the service name, right? So this configuration is something that we need to change, because this localhost is something that I can pass inside, right? Like if the environment variable is not available, I can pass on localhost :9296, otherwise the service name of the Kubernetes. So what I'll do, I'll pass this HTTP information as well here. Why to keep it, right? So now this will make it much clearer that if the environment variable is available, we are going to pass a URL, else this is a localhost URL we need to use when you're working with the local. Okay, this is the one configuration that we have added. We just modified it. Okay, why we modified it? Because we are going to pass each and every information from the configuration itself. Nothing is going to be hard coded. Okay, now all the configuration that you see, for all this configuration we are going to create a config map. Okay, a config map is going to be created that will store all your configuration, and that config map we will use in our deployments that we create. So this is something that we are going to create for this config map for config server URL. Is there any other information that we can use? Rest of the things look okay to me in the cloud gateway. Let's check for the config server. In the config server, we'll go to the src main resources and the application.yaml file. This is the GitHub URL, directly can be accessible, right? And here we have defined the Eureka server address and the localhost information, that's the localhost path. This is also looks good, right? So Eureka server address is also something that we are going to add as a config map, and that config map we are going to use in our deployment. Similar thing, if you go to the order service and src main resources and the application.yaml file, so here also you can see that we have defined db host here. So this is something that we can pass, right? This is going to be also your config map that you can pass on, right? So this is all fine. Is there anything else? Config server you can define here, right? So here you can see that here we have defined the config server. So this config server, you can see we have just passed the localhost. We need to pass as we defined in the cloud gateway, right? So in the cloud gateway we have defined this way. So this is something that we need to add here. So we'll just copy this and we will add here. Okay, so if config server URL is passed, it will use it, otherwise it will use the localhost. Okay, is there anything else? This is a dev URL for your Okta. This is all fine. This is the same. There is no configuration change required here. Okay, this is all good. Now let's check for the payment service as well. So we'll go to the resources application.yaml. db host is already mentioned, and here we need to add for the config server. So let's add for the config server. Okay, config server is defined, everything else is good. Then we can go ahead for the product service. In the product service we'll go to the src main resources application.yaml file. db host is mentioned, and config server we will define as we define in the other service. Okay, so this is all defined. Now let's go to the service registry And in the service registry, we'll go to the again src main resources application.yaml file. And here you can see that we have defined the host name. Now this host name would be for your local host, but when you're working with the Kubernetes cluster, we need to define, other than localhost, you need to pass the environment variable as well, right? So we need to define that. So let's define it. So we will define, instead of localhost, we'll define hostname localhost. Okay, what this will do is this will be your environment variable. So if this hostname environment variable will be there, it will be used that Eureka, otherwise localhost Eureka. So this is what we have defined. Now these are the only applications that we have that needs change. Now what we have to do is, once we define all this, all the configuration that we have defined, like all the environment variables whichever we needed, now we need to build everything and we need to store our images in our Docker Hub. So we need to run all the commands again. So I will open the terminal again and I will go to cd cloud gateway first, and I will run the command that is mvn clean install zip build. So I will do this for each and every applications again. So cloud gateway is done. Let's do for the config server. I will go to the config server and I will run the command mvn clean install zip build, and we will wait for it to complete. And config server is completed. We will go to the order service. So mvn clean install zip build, and the order service is also completed. We will go back and we'll go to the payment service and we'll do the same thing, mvn clean install zip build. And for the payment service is also completed, we'll go for the product service. And we'll run the command mvn clean install zip build. And for the product service is also completed, we'll go back and go to the service registry and we will do the same thing for this as well. And you can see that this build is also successful. And now if we go to the Docker Hub here, let me just sign in. Okay, you can see that everything is published there few seconds ago. Service registry, product service, payment service, order service, config server and cloud gateway, everything is available here, and we will be able to see our latest tag information. You can see that latest is there and the snapshot version is there. So we are going to use the latest in all our Kubernetes configuration. So this was all about the prep work here. Now we will go ahead and start creating our files. Now let's start with the service registry first. Okay, so for each and every component we are going to create the different files. So in the Kubernetes directory, which is k8s, let's create a new file and we'll define service registry stateful set. Okay, because we are going to create a stateful set, so that's why I'm defining statefulset.yaml. Okay, this is a sample file we have created. Now here we need to write our code, and trust me guys, writing the Kubernetes YAML configuration is really easy. This is going to be the most easiest part in our entire course. Okay, because we are going to use the snippets and we are just going to change a minor configurations. What we used to do is, earlier we used to write the API version information, right? We used to write API version, then kind information we used to give, then we used to give the metadata information, right, and the spec information and everything. We were giving everything here, but now with this plugin that we have added, that is a Kubernetes, we can create everything easily. So suppose if you want to create deployment, just write deployment. You can see that you will get a suggestion that is Kubernetes deployment. Just enter, you can see that your entire configuration is ready, and you can see you are getting the highlighted as well. So here you can give the name, that is service registry, and you can see that most of the thing is ready. You just need to pass the image information and the port information. Your application is running. You can see your deployment is created. Similarly, if you want to create a service, then just define the service and your service is created. You just need to give the name of your service and which app it's going to target, and the port information and the target port information. If you want to create a stateful set, then just define stateful set and the configuration for the stateful set is created. You can see how easy it is to create all the configuration files, and all the templates and everything will come. We just need to provide a proper information. Okay, so this is what we are going to use here. So make sure you use it because we already covered the basics of the YAML configuration. So now we are going to use this, and in your project as well you should be using this, so you'll be able to create these configurations very easily and very quickly, and you will not get any YAML configuration error as well. As we know, in the YAML, indentation should be perfect, right? So here you can see everything would be indented properly. We just pass the information, that's it. So now with this service registry we are going to create a stateful set, right? As we talked about earlier, your service registry is going to store all the state of each and every microservices. This is going to be your stateful set. And with the stateful set, we also saw that we have to create a headless service, so both can attach and we get a sticky identity to connect to it. Okay, so this is a stateful set and we will give the name here. Let's give the name, that is Eureka. Okay, and we will give the name here as well to Eureka, and the service name we will give is Eureka. So we just define the stateful set and we give the name as Eureka. We give the name of the app as also Eureka, and the replicas I just need one. Okay, and in the template information as well we gave the metadata information as Eureka. Okay, now here we need to add the containers. In the containers we need to give our image name. Okay, so here in the image we are going to give as daily code buffer / service registry. If you go here, right, you can get this service registry. Okay, you can just copy this and you can add. So we have just defined that, and the port information, this is going to be 8761. Okay, we don't need the name of the port. Okay, so we just can remove this. We are not going to work with the volumes for the service registry, right? That's why we can remove that as well. All these things we don't need it. And here you can see that your stateful set is ready. Now we need to create the services for these pods that we are going to create. So when you're working with a YAML file, and if you want multiple YAML files in a single file, you can separate it out with /. Okay, and here you can create another YAML file. So now here we are going to create a headless service. So with a service we will be able to add a service, and this is going to be my Eureka service. This is also going to be my Eureka service. Now as we are going to define this as a headless service, right? So for that we need to define the cluster IP. So in the cluster IP we need to define as none, because now once we define this cluster IP as none, this is going to be your headless service. If you see here, you can see that cluster IP is the IP address of the service and is usually assigned randomly, but valid values are none, empty string, or a valid IP address. Setting this to none makes a headless service, that is no virtual IP. Okay, which is useful when direct endpoint connections are preferred, not proxying it to the required. So we are going to directly use this endpoint, so we have defined this as a cluster IP. Okay, and the port information we are going to use is as 8761. And we are not targeting any port here because this is something that we are going to use. This is going to assign to this stateful set. Okay, so that's why we will just give the name here, and this name is also going to be Eureka. So this is what we define a stateful set and a headless service. Now this is all the configuration we need for the Eureka service. Okay, but if you want to access this Eureka service, that is service registry, outside your Kubernetes cluster, we need to have one load balancer service or a node port service, right? We saw that we have the internal service and we have the external service. We define one internal service as a headless service, which will give a sticky identity to connect for other applications, right? Other applications can connect to it. But now if I want to, or any user want to access this service registry, they will need one services that can be exposed outside the Kubernetes cluster as well. Okay, and which can connect to this 8761 port of this stateful set. So for that we can define one more service. Okay, I can define one more service, and I can define name as Eureka load balancer service. Okay, and the selector I will keep as Eureka. The port information I will give as 80. What I want is my service, right? This service is going to run on port 80. 80 is the default HTTP port. Okay, so that's why what I want is it should run on default HTTP port, and the target port I'm defining is 8761. It should go and connect to the 8761 port. And what I am defining is type of this service. So I'm just defining this is a node port service. You can also go ahead and create the load balancer service because that's the ideal way you should do. But I'm just showing you that this way we can create the node port service, and in the other component I will show you how to create a load balancer service. So you will get the both examples, like how we can create both the different services. Okay, so that's the reason that I have defined node port over here. So you can see that we just define one configuration file for our service registry. The entire configuration of the service registry is done here. We just created a stateful set. In that stateful set, we define the name of the stateful set and the pod information, how many replicas we need, and the image we want to use, and the container port it's going to expose. For this, we define the headless service as well. We define headless service with cluster IP as none, and we gave the name as well. That is going to be Eureka. Okay. Now you can see that as the service name is Eureka, we have defined in this stateful set, in the service name, we have defined the Eureka. Okay. So now whenever we want to access this service registry, we can access using Eureka -0, because that's going to be your service, because every time when a stateful set is created, the pod is created with the stateful set, it will be appended with -0 rather than the hash value. So we can access using Eureka -0 dot service name, that is going to be your Eureka. Okay, so that way we will be able to access this, and we will add that configuration as well, so you will get better understanding. Other than this headless service, we created a node port service as well. So this node port service is for the external users, like external users can connect to this service registry and can see, okay, which are the applications are connected to this service registry. This is for the external traffics coming to the Kubernetes cluster, and this is going to be used internally to connect all the applications. Now this service registry is done. Now let's go ahead and add the configuration for the config server. Now for the config server, let's go ahead and create a new file. So within this KDS folder, I'll go ahead and create a new file, and I will name as config server deployment.yaml. Okay, and for this config server, what we are going to do is we are going to create a deployment, and for that deployment we are going to create one service. Okay, easy stuff. Now to create a deployment, we'll just use the deployment snippet, and the deployment is created. We will give the name as config server app. Okay, simple. Now we need to give the name of the image, and the name of the image I will be giving is as daily code buffer /config server. Okay, this is something that we have defined here as well. We just uploaded it, right? So this is going to be your config server. So this is something that I have copied and added here. Okay, and you can see that the resource limit is also added, like what memory and CPU it should use. Okay, ideally when you're working with the production application, you should define like how much memory it should use, but for the simplicity for now, because this is something that you need to tweak, like how much memory your application is using, you need to make sure that you do the load testing and everything. Based on that, you will get to this particular number. But for simplicity, we have only 6 applications and we can deploy each and everything within the Kubernetes cluster. I'm going to remove this, but you can add it, okay, based on your requirement. It's nothing but a resource limits and the memory information, how much memory you need and what is the CPU you need. So I'll just remove this for now. And the port information, which port my config server is going to work. So my config server is going to work on port 9296. So this is defined. Now with this deployment, we need a service as well, right? So we'll define a service. So we'll just use this service snippet here to create a service, and we'll name as config service svc, and we will name this as a config server app. Okay, and my service is going to run on port 80 and the target port is 9296. This is the one, okay, above one. This will go here and my service is going to run on 80. By default, when you don't define any type, this is going to be your cluster IP service, because this is going to be running within your cluster itself. Okay, you can see your service is also created and your deployment is also created. You can see that we just changed couple of details. We just gave the name here and we just gave the image information here and the port information, okay, like which port it's going to run. Here as well, same thing. When we created a service, we gave the name of the service and which selector it's going to use. So the application that we are going to use is config server app. This is something that we have defined here. Okay, and the port information that we defined. Now if you go to the config server and if you go to the src main resources and the application.yaml file, if you come here, you can see that we have defined one environment variable, that is the Eureka server address. Okay, so this is something that we need to define, right? Because this is the environment variable that we need to pass as the configuration. Okay, and as we defined earlier as well, that all the configuration that we are going to define, that configuration we are going to add using the config map, and that config map we are going to use as the environment variable. Cool, right? So let's define this. What I will do is I will go here and in the Kubernetes folder I'm going to create a config map. Config map is nothing but to store the default configurations, and whenever you want to store any passwords or any credentials or sensitive informations, you can create the secrets. Okay, so let's go ahead and create a new file that's going to store config. So I'll just define config maps.yaml. okay, and here to create a config map we are still going to use the snippets, so we'll just define config map, and here you can see that the config map is created. It's very easy. So we'll give the name of the config map and we will give the data as key and value pair. Okay, so here I'm defining the name of this config map as Eureka CM, that is Eureka config map, and then data, in this data I'm defining key and value. So key I want to define as Eureka service address, and the value I need to define as this. Okay, http://eureka-0. okay, that means whatever the service that we have defined, right? Eureka-0 dot Eureka. Okay, this is what we have defined. So in the config maps, :8761 is the port information that we are going to use, and /Eureka is the path. Okay, now we just define this config map. So this config map will be created and this config map will store this data information. We can add lot of data here, okay, within the same config map, because config map will just store each and every data in a key value pair. Now this config map we can use in our config server to set in the environment variables. Now to set the environment variables here, after this port information we can store the environment variables. Okay, and within this environment we can give multiple names. So first name we can give, what was the name? So if I go here in the application, this is the Eureka server address. So I'll just copy this, and this is something that I need to add. Now for this Eureka server address name I need to add the data value to it, and this value I need to get from the config map that I have created. So let's see how to get that information. So here I can define, I want to get value from config map key ref. Okay, config map key ref, and within this config map key ref I need to define the key. And what is the key? Key is this Eureka service address, and we need to pass the name as well. What is the name of the config map? So the name of the config map is Eureka CM. Okay, so this two information is needed. So with this information you can see that the value will come from config map and it will set to the Eureka server address as the environment variable. So here your entire configuration for your config server is done. Your deployment is created and your service is created with your config map and that config map as the environment variable as well. Cool, right? Now let's add the configuration for the cloud gateway. Now to create the configuration for the cloud gateway, I will create a new file here in the Kubernetes folder. I will create a new file and I will just name as cloud gateway -deployment.yaml. Okay, and the file is created. Now this particular cloud gateway deployment will be again having the deployment. So we are going to use the deployment snippet to create a deployment, and we are going to give the name as cloud gateway app, and the file is created. Now we need to give the image name. So let's give the image name. So the image name is going to be daily code buffer / cloud gateway. Okay, this is something that you will get when you uploaded. Same here, we are going to remove the resource limit for now because we need all the resources, and the port information is going to be 9090 because cloud gateway is going to be running on port 9090. You can see that your deployment is created. Now let's create the service. So we are going to use the service snippet here, and The name of the service would be Cloud Gateway SVC, and the name of the app would be Cloud Gateway App, and the port would be 80 and the target port would be 9090. Now, till now we saw the example to create a cluster IP, we saw the example to create a node port as well, and we saw the example to create a headless service as well. Okay, now this cloud gateway ideally will be your API gateway, and all the external traffic will come to your API gateway, and from the API gateway only all the traffic will be routed to your internal service. So this will be your forefront of your entire microservices. So for this we are going to create this as a load balancer service. For that, in the specs we are going to define type as load balancer. That's it, your load balancer service is created. You can see that how easy it is, right? Now this particular cloud gateway will also have some configurations on some environment variables, right? So if we go to the cloud gateway and if you go to the src main resources and the application.yaml file, you can see that we have one config server URL defined. This is going to be one environment variable, and the other environment variable is going to be what we have defined in the config server. Okay, so if we go to the config server application.yaml and if we go to this configuration, right, in the application.yaml file, you can see that we have defined a configuration, right? And here we have also defined the Eureka server address, right? So two environment variable is needed. This is something, one environment variable we have already defined that we used in the config server, right? Now we need to define for the config server URL as well. So let's go ahead and define that. So what I will do is I will go to the K8s, I will go to the config maps, and here I can create one more config map, right? And this config map will store the data for the config server. So let me just create a config map, and this config map I will name it as config map. This is going to be a config server, and I will give the data as config URL and the value as http:// name of the service. Okay, this is the name of the service we created for the config server. Okay, you can see that this is the name, right? Config server SVC. So this is the same name that I have given here. I will just rename this to here. This makes more sense, right? Yeah, config server SVC. So this name and this name in the config map should be same. So you can see that we are able to access each and other resources, each and other services by directly the name of the service itself, right? We do not have to provide any port or anything. By just name we will be able to access it. So that's why we have just defined config server SVC here. Okay, now this config CM we can use in our cloud gateway. First of all, what we'll do is we'll go to the config server and we will copy this, because this is one environment variable that we need, right? So we'll copy this, we'll go to the cloud gateway and we will add one environment variable. Okay, one environment variable is added. Now I will copy this and I will add it again. Okay, and I will change the name. So the name is config server URL. So I'll just copy this and I'm going to give this config server URL here, and the key is going to be config URL and the name is going to be config CM. You can see that the cloud gateway configuration is added. We define the two environment variables, that is the Eureka server address and the config server URL as well. Okay, and these services also we have defined. So you can see that your cloud gateway is also done. Now in the next video we are going to do the configuration for our order service. Now for the order service, let's create a new file here and we'll define as order service deployment.yaml file. Okay, and this YAML file, order service, is also going to be your deployment plus service. So let's create a deployment and we'll give the name as order service app, and we are going to give the image name. So let's give that, and the order service image name is going to be daily code buffer / order service. I'm going to remove the resource information for now, and the container port is 8082. Okay, so your container port is also defined. Now we need to define the service. So let's define service here and we'll give the name order service SVC, and the name of the app as order service app. The port is going to be 80. It is going to be HTTP port, right? Default. And the target port, what it's targeting? It's targeting 8082. Cool, right? You can see the configuration is done. Now for this as well, we need both the configuration as we defined in the cloud gateway. So that is going to be your config CM as well and your Eureka server address. So this all things we need. So we'll just copy this and we'll go to the order service and we will add all this information. Okay. So you can see that your configuration is done. Now, one thing is still remaining. If you go to the order service, so let me just go to the order service, and in the order service, if you go here in the main Java resources, okay, we have the DB host as well, right? Which particular DB we need to connect to. So for this will come later, but we have added for the config server URL and we added for the Eureka server address. Similar thing, let's do the same thing for our payment service and product service, and then we'll come for the DB host. Okay, so let's go ahead and create for the product service and the payment service. So let me just create for the new file product service deployment.yaml file, and in this product service we need to create a deployment and service. So let's create a deployment first, and the name would be product service app, and we need to give the image name. So let's give that. So the image name is product service, the port information. So let me check the port first. Okay, so for the product service we have the port as 8082. Sorry, this is payment, right? For the product service is 8080. So we'll go to the product service here and the port is 8080 and the product service is defined. Now let's add the service for it. So we'll just define service layer here. Okay, and the name of the service would be product service SVC, and the name would be product service app. It's going to be on port 80 and the target port would be 8080, and this is also going to be have the environment variables. So we'll go to the order service and we'll copy the same environment variables. So this is something that we need. Okay, environment variables are added. Now similarly we need to do for the payment service as well. So let's go ahead and do for the payment service. So we'll just define payment service deployment.yaml. Okay, and for here as well we are going to create a deployment in the service. So let's define the deployment and the name of the deployment as payment service app, and the port information is 8081. We don't need the resources here, and we need the image name. So we'll define image name here, that is going to be payment service daily code buffer / payment service. Okay, and now we need to define the service. So service we have defined payment service SVC and payment service app. Okay, and the port information is going to be 80 and the target port is 8081, right? 8081, and this also will need the same environment variables. So let's go to the order service and let's copy this environment variables. So we'll copy this, we'll go to the payment service and we'll add the environment variables. So you can see that the environment variable for the payment service is also added. So now the order service is created, payment service is created, and the product service is also created. Cool, right? Now let's go ahead and add the configuration for the MySQL, because that's going to be very important. And with that MySQL, once that is added, we need to add the configuration back to our order service, payment service and product service to connect to that MySQL. Now let's add the configuration for the MySQL. So let me just create a new file and just define MySQL deployment.yaml. Okay, now here we need to do a lot of things, because this is going to be your stateful application and you're going to store the state of the application. And when we are going to store the state of the application, we are going to create a stateful set with the headless service, plus we are also going to create a volume as well. So all the data will be stored in that particular volume outside your cluster. Okay, so what we will do here, we are going to create a persistent volume. Okay, then we are going to create a persistent volume claim. Then we are going to create a stateful set for our SQL, MySQL. Okay, and then we are going to create a headless service for that. And we are also going to create a configuration, whatever the configuration is required for our MySQL. Okay, so these are the details that we are going to create. So first, let's start with the persistent volume, then persistent volume claim, then stateful set, then headless service and the configurations. So let's add those things. So first, to create a persistent volume, we are going to use the snippet. So persistent volume. Okay, so you can see that these are the details that we need to add for the persistent volume. By default, you can see that it is using the NFS storage here, but we are not going to use the NFS storage here. So let's define the name MySQL persistent volume, and the size information I am giving here as 1 GB. Okay, so we are going to remove the information which we don't need. So I don't need volume mode here, so I'll just remove this. I don't need persistent volume reclaim policy, I can remove this. I need storage class name as manual. Okay, you can give any name here. Then I don't need this mount option with the NFS. I want to add the host path because I'm running in my local and I am adding the path of my host machine. Okay, so I'm just defining host path here, and you can give the path of your system wherever you want to store those volumes. So I'm just giving this path, and if you are in the Mac, you can give /mnt/data. Okay, in Unix, either Mac or Linux. Okay, you can give this way. Currently I'm running in Windows, so I just given this way that ctemp test files, it will add all the things. So this way you can give the data, and I will define type here, define as directory or create. Okay, so here you can see that your persistent volume is created, where we define the kind as persistent volume, we give the name, we give the storage, like we need 1 GB of storage, and we give the storage class name and the access mode that we require, that is read write once, and we give the path information where we need to create a volume. Okay, we just give the path, so your path you need to give. Okay, and we give the type as directory or create. So this is all the information we need. Now we need to create a persistent volume claim, because based on that claim we can use that in our MySQL deployment. So let's do that. Let's create another file and let's define persistent volume claim. So you can see that all the information came here, and I'll give the name as MySQL persistent volume claim, and the storage I'm going to use is as 1 GB. Okay, this is the same that we need to give. And then I need to give storage class name rather than volume mode, and the access mode as read write once, and your persistent volume claim is also created. You can see that how easy it is, right? So you just need to give this information. So with this storage class name and the storage that we have provided, it will get this particular storage information. Now we need to create a stateful set for our MySQL. So let's define the stateful set here, and we'll just define MySQL app name as MySQL, service name as MySQL. Okay, and the replicas I need one only, and this information we need to give. So let's define all this as well. So within this template, in the specs container, we need to give the image as well. So let's give that. So image I'm going to use as MySQL 8.0, and the ports I'm going to use as 3306 because that's the default port exposed, and the port name I'll give as MySQL. Okay, and then we need to give the environment variable as well. So let's give the environment variable, and the environment variable name would be MySQL root password, because whenever you are setting up your MySQL, you need to give your root password. Okay, and the root password which I have given in my applications, right? If I go to the order service and the application, you can see that I have defined root. Okay, by default the username would be root and the password would be root. So let me give the value as well, root. Okay, So environment variable is set. Now we need to mount the volumes as well. We will come to that. Now whenever we want to mount the volumes, we need to first define the volumes as well. Okay, currently volume claim templates is defined, but we are going to remove this and we are going to add the volumes to it. Okay, so let me just remove this thing and let's define volumes. And within this volumes we can define the name, and the name I will be defining is MySQL persistent storage. Okay, and this will have what? This will have the persistent volume that we have created, persistent volume claim. So let's define that persistent volume claim, and the claim name. What is going to be the claim name? This is going to be the MySQL PVC. Okay, so one volumes we have attached. Now this particular volume I can use in the volume mount. So in the volume mounts I can give that I want to use MySQL persistent storage, and the path should be var/lib/MySQL. Okay, where it is going to be installed. Okay, within the container itself. So that path we have given here. So you can see that we created a persistent volume, and for that persistent volume we created a persistent volume claim, and we created stateful set. In that we define that we want to use the MySQL 8.0. We define the port information and we define the environment variable as well, and we define that within this stateful set we are going to use these volumes, and this volume is going to be mount here. Okay, so that mount we provided here. Now let's create the service for it. So let me just create a headless service here. So this is going to be the service, and this is going to be the MySQL service. App is going to be the MySQL, and the ports is going to be 3306. You don't have to give the target port here. Okay, and in the specs I'm going to give cluster IP as none, because this is going to be your headless service. Okay, now your service is also defined. Now one more thing we need to configure here. Okay, this is going to be really important. Now what I want to do is I want to run a scripts, okay, when I start my application, because what scripts I need to run? I need to create the database actually. Okay, so if I go to the order service, and if you see here in my application I am using the payment DB. Similarly for the order I'm using the order DB, and for the product I'm using the product DB. So all those three databases I want to create, all those schemas I want to create in my database server. Okay, so when I want to create it, when I am starting my container, right, for the MySQL, at that time if those databases are not created, I want to create it. Okay, so for that what I want one script, and that script I need to attach as a volume in my MySQL. So that is something that I want to do. So I want one script, and that script I want to attach as a volume here, and that is something that I want to execute, okay, when the server starts. So for that what I need, I want to attach a script. For that I will create a config map where I will define some data, and that data I will use as a volume. So let me define here as a config map. Okay, and I will define as MySQL init db config map. Okay, and in the key I'm defining as init.sql, and I'm defining pipe here, and here I can define my scripts. So these are my scripts. Okay, you can see that it's simple scripts. Create database, if not exist order db. Create database, if not exist payment db. Create database, if not exist product db. So these are the scripts. Cool, right? And these scripts you can see that are part of init.sql as a key of MySQL init db config map. Okay, and this config map I can use as a volume, and I can attach as a volume mount. So here I can use name as MySQL init db, and I need this information from the config map. Okay, and the name of the config map, that is going to be MySQL init db cm. Okay, so this config map I attached as a volumes here. Now this I can use in the volume mount. So I can use here hyphen name as the MySQL init db, and in the mount path I have defined here. Okay, now you can see that this is something the initdb file that I have used. Okay, so this is just a basic configuration. When you Google for it, you will get all this information, how to mount your initial scripts, and you will get all this information from the Kubernetes documentation itself. It is from there and only. Okay, so you don't have to worry about like how we will get all this information. Each and everything is available in the Kubernetes documentation. I have just removed all the unnecessary details to just avoid the complications. Okay, so hope now everything is clear. We will just go through it once, like what we did. We had to create all these things, like we needed to create a persistent volume to define our storage. We needed to define persistent volume claim. So with that claim, we can get the access to that storage and we can use it in our deployment. That is the pods that we are going to create using the stateful sets. Okay, and then we had to create the headless service with a stateful set and the config map. So here we define the persistent volume, we gave the name, and we define that 1 GB size we need. We gave the access as a read write once with a storage class as manual, and we gave the path information, like this is a path I need to create a volume for. Okay, and then we created a persistent volume claim. This particular persistent volume claim will use the information like storage and the storage class name to connect to this, or to get the information from this persistent volume. Okay, so this will connect to this. Now we created a stateful set. In this stateful set, we defined that this is going to be MySQL, and we give the service name as well as MySQL. And with this MySQL service name, we are going to create a headless service. We defined we need one replica set, and we give the MySQL 8.0 as the image. We define the container port as well, that this is going to be running on 3306, and we give one environment variable that MySQL root password should be root. Then we define the volumes. Okay, whatever the persistent volume claim we created, we use that to attach as a volume here. Okay, and similarly we created one config map here, and this config map is nothing but a config map creating the scripts. So these are the 3 scripts that I want to execute when I start my SQL, and that I have attached as the init.sql data. And this MySQL initdb config map I used as a volumes here, and this volumes I have attached as a volume mount here. Okay, so everything is attached here, and alongside that I had created a headless service defined as cluster IP none, which will point to 3306 with the name MySQL. Okay, so you can see that your entire configuration for MySQL is completed. Now let's use this configuration to connect our order service, payment service, and product service to this MySQL. Okay, that also we need to do. So whatever we defined, right, like headless service, that is the MySQL, and the service as MySQL. So what it will do is it will start as MySQL-0.MySQL. That is going to be the host name for this SQL. So for this DB host, we need to define a config map, and that config map we can use as the environment variable in our different services. So let's define a config map here. So I'm going to create a config map. Okay, new config map, and I will name this as a MySQL config map, and I'll define host name here, and host name I'll define as MySQL-0.MySQL. As we defined similar thing for the Eureka as well, right? Eureka-0 Eureka, similar thing we defined for the MySQL as well. Now this is something that we can use in the order service, payment service, and product service. So let's go to the order service, and we need to have one environment variable. The environment variable name was DB host. So I'll just copy this and I'll paste here, and this is going to be DB_host. Okay, and the config key map reference key is going to be host name, and the name would be this. Okay, so config name is MySQL CM, the key is host name, and all this thing will be attached to the DB host. So let me just copy this and go to the payment service and attach it here as a DB host. I'll go to the product service and do the same thing. Okay, DB host is attached here. Okay, so you can see that all the configurations are done now for my MySQL. Okay, so all the configuration for the order service, payment service, product service is done with the MySQL connected. We have service registry created, we have cloud gateway, and config server is also created. Now we need to connect to the Zipkin as well. So we need to have the Zipkin deployed as well. Zipkin will collect all the distributed logs. Okay, so let's create a deployment file for the Zipkin. So I'll create a new file and I'll just name as a Zipkin deployment. Now for this Zipkin, we will be having a deployment and a service that each and every services can connect to. So let me just create a deployment here and I will name it as a Zipkin. Okay, and here let me just remove these resources here because I don't need these resources. The port information is going to be 9411 because here is something Zipkin works. Okay, the image name we need to give, that's going to be the open Zipkin. So let's define that. Okay, now for this, let's define the service. So here I can define service here, and I can define Zipkin SVC, rather than I'll just define Zipkin only. Okay, so directly with Zipkin I can attach, and here Zipkin, the port is going to be 9411, and this is also going to be 9411. I'll define SVC only because this is something that we have attached as a SVC to each and every services, right? So this service is also defined, and this is going to be your cluster IP service. Now suppose if you want to access Zipkin provides a Zipkin dashboard, right? So if you want to access the Zipkin dashboard from the external traffic, like if a user or all the developers want to access this Zipkin server, then cluster IP is not suitable. So for that we need to have a load balancer service also created, so external user can connect to this Zipkin service, right? Because this is going to be your cluster IP, which is going to be used to connect to each and every different services that we have, right? So let's define that load balancer service. So I'll just define a service here, and I'll define Zipkin load balancer service, and the app is going to be Zipkin, and the port information is going to be 9411. Target, this is also going to be 9411. Okay, so here you can see that we have defined the type. Here we can define type as load balancer. So your load balancer service is also created. Okay, so we created two services here. Cool, right? So your Zipkin is also done. I have defined the wrong spelling, so let me just correct it. Okay, now let's go ahead and add the configuration for the Redis, because we need a Redis as well to be deployed, because we are going to use the rate limiter with Redis, right? So let's add the configuration for that as well. So here I'll create a new file, and I'll just define Redis deployment.yaml. okay, and here I'm going to create a Redis deployment and the service for it. So let's define the deployment here, and I will name as Redis app, and here let me just remove these resources because I don't need it, and I need to give the image, and here I'm going to give the image as Redis 7.0.4. This is all things you can get from the Docker Hub. Okay, like whatever the version you need, you can define here, and the port information I need is 6379 because that is the default port it's going to expose. Now whenever I want to start as a Redis server, okay, not as a CLI. Okay, so I want to run that command as well, like it's going to run as a server and we can connect to it. Okay, so let's define the commands for that as well. So in the command I can define this as a Redis-server. This is the command that I'm going to run. If there is any argument, I can define the argument as well, and in the command I'm going to define protected mode as no. Okay, so these are just the basic details. You will get all these details when you search for it in the Redis documentation itself and the Docker Hub documentation. Okay, whenever you will go to the Redis image page, you will get all this information. Okay, so we just define one container with the Redis 7.0.4. it will be exposing on 6379, and we are going to run the Redis server as a command. Okay, now we need to have a service for this as well. So let's define that. This is going to be Redis, and the app selector is going to be Redis app. Port is going to be 6379, and this is also going to be 6379. Okay, all the port information we have defined here. Now here you can see that as we have defined that we are going to use Redis here with the name Redis. Okay, we need to add the configuration in the Cloud Gateway, because Cloud Gateway is the only application that uses Redis. So Cloud Gateway needs to know that it's going to connect here in this Redis, okay, with the Redis as a service name and the port as 6379. By default, if you don't provide, it will go to check in the local host 6379. Okay, that's the auto configuration from the Spring Boot. But if we want to connect using this in the Kubernetes cluster, we need to define that configuration. So let's go ahead and define that configuration. So what I will do, I will go to the cloud gateway. In the application.yaml file, I will define this configuration, that this is spring.redis.host is Redis and spring.redis.port is 6379. Okay, so that's the configuration that I have defined here. Okay, this was missing, so now it will be able to connect to Redis on this port information. Now once this is done, we need to again go to the cloud gateway. So I'll go here, cd cloud gateway, and I need to run a command mvn clean install zip build. So we will get this information added to our Docker Hub. Now similarly, we need to add the configuration for the Zipkin as well. We define the Zipkin here, right? So if we scroll down here in the Kubernetes, in the Zipkin deployment, we define this Zipkin service, right? So currently by default, we have not added the configuration because it was working with the default configuration, right? But now as we are everything adding to the Kubernetes cluster, we need to define in our config server that where we need to go and connect to Zipkin. So that configuration we need to add. So for that, we will go to the Spring App Config. This is our configuration provider, right? So here we can edit the configuration and add our configuration here, that we are using Spring Zipkin base URL Zipkin-svc, because that is something that we have defined, right? If we go here, we have defined as a Zipkin svc. So this service name we need to give here. So Zipkin svc colon 9411. 9411 is our port information. Okay, so once we define, it will try to connect to the Zipkin. So let's commit these changes. Okay, so now we'll be able to connect to Zipkin as well, and now we will be able to connect to Redis as well. So now all the configurations are done. Now till now we have not deployed everything yet, but now we are going to deploy each and everything to our Kubernetes cluster. I am super excited. Hope you are as well. Now let's deploy each and everything and let's see everything is working fine or not. So we have all the files created. So we'll go to the terminal and let me just clear this, and we should be in the correct directory. Let me just check it here. So yeah, within GitHub/Spring Boot Microservices, we are correct. Okay, so I'm here, and if I do ls here, this is, let me go back here. Okay, currently we have the Kubernetes k8s directory, and in that we have all the files available, right? So that is something that we need to deploy. So if we clear this and if we do kubectl get all, you can see that we have nothing available. So no resources is available. Okay, but we need to deploy each and everything. Now we have 6 to 7 files available, right? And we need to deploy each and everything. But before that, I will show you one thing about the Kubernetes dashboard. Kubernetes dashboard will get you to see each and everything happening in the dashboard available. So to start the Kubernetes dashboard, the command is minikube. Minikube provides us the dashboard functionality. So we will be using minikube dashboard here to start our dashboard. Okay, so once we do this, we will get the dashboard. So let's run this, and you can see that the dashboard is started currently. Okay, currently if you see, there is no pods available, no replica set, no stateful set. Okay, nothing is available, and here you can see that you will get a different namespace available and everything. Okay, so all these details about the Kubernetes cluster you can get from the Kubernetes dashboard, and this will be very helpful to identify and visualize all the different resources available. You can get each and everything from the CLI commands as well, but this is also a good way to get all those information. So what we will do is we will go here and we will deploy each and everything. So to deploy, the command is kubectl apply -f, and then we need to give the file name, but we have multiple files, right? So rather we will just provide the folder, like deploy everything within the Kubernetes folder. So all the files we have, right, all the configuration files, everything will be deployed. So if I hit enter, you can see that everything is deployed, and we have one error as well. So let's try to resolve that. So in the MySQL deployment.yaml, error validating unknown field volumes. Okay, so this is something that we need to fix. So let's try to fix it. So if we go back to the MySQL.deployment and volumes, this is something that we need to solve. So let's try to fix it. The issue is only with the indentation. Okay, so this volumes is where at which level? Okay, specs level. It should be at the containers level. Okay, so I will just add tab here. Okay, now you can see that everything is aligned. Now it should work. So I'll just save this and I will go back and I will apply all the configuration back. And now you can see that everything is successful. Now you can see that most of the things are unchanged. Okay, but you can see that the stateful set for MySQL that is created. Okay, so now if we go here, so you can see that all the configurations are applied. Now if I, let me just clear this, and if I do kubectl get all, I should get all the information. You can see that all the pods are there, all the services are there, all the deployments are there, all the replica sets are there, and all the stateful sets are there, right? Every information you can see from here, and you will get the status and each and everything. Similarly, you can go to your Kubernetes cluster, Kubernetes dashboard, sorry, and here also you can see all the information. You can see all the pods available and the status of each and every pod. You can see everything is running currently. Okay, and you can also see replica sets available, right? All the replica sets. You can see stateful sets available, right? MySQL, Eureka. You can see the services available. These are all the different services available. Okay, and the type and everything you can see here. You can see the different config maps as well. So these are all the config maps. Okay, and if I come here to the deployments, okay, you can check the logs as well here. So if I want to check the logs, I can scale, edit, all those things. And if I go inside this, you will get the information about the deployment. This deployment will be having a pod, right? You can see the pod status, 1 updated, 1 total, 1 available, all those information. And if you go to the pods, okay, suppose if I'm going to cloud gateway, if I go here, you will get the information about each and everything. You can see that how many times it was created, how many times it was started, because first time some of the information may not be available, so it has to restart. But at the end you can see everything should be working completely fine. If you want to check the logs, if you go to the pod section, and from here you can check the logs as well. Okay, you can see all the logs and everything. Okay, if you go to the services, right, so you can see that we have the Eureka load balance service, that is a node port, so we can forward the service. By default, Minikube doesn't provide us the functionality to run this. We need to do the port forwarding. Okay, so we need to expose, or we need to create a tunnel from the Minikube to see our services, so that we will do. But ideally you can see that everything should be deployed correctly. Okay, if you feel that there is an issue, you can delete the service or you can delete the pod and it will recreate for you and it should solve the issue. Okay, and if still you are not able to figure it out, you can always ping in the discussion forum. Now once this is done, everything is deployed. You can see everything is green. Okay, and if you come here and if you open the new terminal and if you do kubectl get services, okay, these are the different services available. Now you want to expose Eureka load balancer, Eureka service. Okay, so for that what you need to do is you need to run the command with the, this is only for the Minikube. Okay, that is Minikube service and the name of the service. So what it will do is it will create a tunnel for you. So with that tunnel you will be able to access this service within the Kubernetes cluster. So once we run this, you can see that it started a tunnel for us and we are able to access the Eureka server. And you can see that each and every service is connected to it. API gateway, config server, order service, payment service and product service, right? Everything is up and running. And we got one port information as well, like on this port the tunnel was opened for us. Now one more thing we can expose is, let me open a new terminal and let's do kubectl get services. One more thing I can open is cloud gateway, because the cloud gateway, you can see it's a load balancer service and all the applications should connect to that. So all the external traffic also should come via cloud gateway. Okay, so for this also I will just do Minikube service and cloud gateway SVC. So the moment you can see that I started the service, we got the port information and everything and it stopped working. You can see that it went to Okta and we got the bad request, because in the Okta we need to define the redirect URL, right? So let's go ahead and define that, because once we define those redirect URLs, then only it will work, right? If you see here, we will get the URL information, right? You can see this is the redirect URL and this is coming as wrong. Our port information is what? 59667. So what you have to do is you have to go to the Okta. Okay, here only you can go to the home page and log in with the account. I log in with Google. Okay, so once you are logged in, you need to change the configuration. So you go to the applications, go to your application microservices. Okay, and if you are not able to sign in at all, then you have to go to the assignments, and here you need to assign the groups. Okay, currently you can see that I am seeing admin and customer. If you're not able to say this, go here and assign the groups to your account. Okay, otherwise go to general and come down here, and you need to change this information. Okay, these two things. So if I just edit this, and I need to change the port information. So this is 59667. So I will come here and I need to change to 59667. Okay, so this port information you need to give. Okay, that is sign out URL and the redirect URL. That's it. Once you do this, save it and just copy this and open incognito mode, and we can log in here. So the URL is /authenticate/login to log in and to get the IDs. Okay, so I'll just hit here and you can see that we got the sign in page, and my user I can get from the directory people, and this is the user that I'm using. So I can pass this user information and I can pass the password and I can sign in. And you can see that I got the authentication token as well. So you can see that now from my Kubernetes cluster, I'm able to connect to my Okta as well. So I'm getting the token as well. Now all our services should work. So now if I open Postman, let's check all our services. Okay, so your port information is 59667. So let me just copy this and give here, and this is going to be your post request. So I'm just trying to execute or create one product here. Okay, and in the body information I have given this particular product information, that iPhone 1200 and the quantity is 10. Okay, and in the authorization I need to give the access token. So let me copy this access token here. I'll copy this, I'll go to the authorization, I'll select auth 2.0 with the request headers, I'll copy the token here. Okay, and now if I try to execute, you can see that I got 201 created. So my order was created. Okay, now if I try to get the order with /2, okay, we are getting the 2 ID, and if I do get here, I should be able to get the product as well. You can see that I'm able to get the product as well. Okay, so you can see that my product is working. Similarly, your order and payment will also work. Okay, and you can see that you are only connected via API gateway, not anything else, and you can see that everything is connected, right? Let's try to expose the Zipkin as well, so we will be able to see the Zipkin as well. So we'll go here, let me see the Zipkin. So I'll just see kubectl get services, and let me expose the Zipkin here. So I'll just do minikube service, and I'll give the Zipkin load balancer service here. And you can see that your Zipkin is also working completely fine. And if you run the query, you can see that you are getting all the requests that we did. Okay, whatever the failures were there, whatever the success were there, everything you can see here. So you can see that everything is completely working fine. Your Zipkin is connected, your Redis is connected, your Okta security is connected, and everything. Okay, your MySQL database is also connected. So you can see that this is how we were able to create each and everything in the Kubernetes cluster. We created just files, and with just one command we were able to deploy each and everything. Cool, right? Isn't it awesome? Now if you want to delete each and everything, right, let me just clear it out. If you want to delete each and every resources, we can use the command kubectl delete -f and the folder. So if we just define create s, and if you run this command, all the resources whatever we have created, everything will wiped out. So you can see that everything is deleted. Alright, so everything is deleted. Now if you go here and if you go to the dashboard, you can see that no resources available, only one default Kubernetes service is there, no pods available. Okay, you can see that they are terminating, so it will be removed. No stateful set is there, no replica set is there, nothing, everything is deleted. Now if you want to create again, it's just one command and everything will be created for you in 1 minute. So you can see that how powerful is Kubernetes. Now currently in our microservices application, you can see that we have a service registry, and this service registry will connect all the services to it, and we will be able to communicate with each other services using that service registry. And this service registry is something that we have created using the Eureka Netflix dependency. Okay, but when we are deploying each and everything in the Kubernetes cluster, Kubernetes also provides us the service registry. So if we want to communicate with other services or the other microservices deployed in the Kubernetes cluster, we do not actually need a service registry, that is the external service registry. We can utilize the internal Kubernetes service registry that has been given by the Kubernetes itself, right? So that means we can avoid entirely one application and we can leverage the service registry provided by the Kubernetes. So let's see how we can use the service registry of Kubernetes and what changes that we need to do in our application to accommodate that. Now firstly, whatever the different services are created in the Kubernetes cluster, we can communicate with different services using the service name itself. So for each and every deployment or the stateful set we create a service on top of that. That's the cluster IP service. So with the name of that cluster IP service, we can communicate between the different microservices. So that is what something that we are going to leverage. So rather than using the service registry, we can remove that service registry, and wherever we have added the dependency of this service registry as a client in all the different application, we can remove all together. We can implement our new implementation without the service registry. Okay, so let's go ahead and do that. So what we will do is we will go through each and every component and we will identify where this service registry, that is Eureka server or Eureka client, is being used. We can remove that and we can do the changes accordingly. Okay, so let's start with the cloud gateway. So now here you can see, let's go to the cloud gateway, and if you go to the pom.xml file of the cloud gateway, if you scroll down here, you can see that we have the Eureka client dependency, right? So I can just remove this dependency because I don't need it, right? I am not going to use the Eureka client now. So let's remove the dependency, and then let's go to the src main resources, in the Java and in the main file. If we have used the enable Eureka client, we can remove that as well. Okay, so let's remove this dependency as well. Okay, so you can see that dependency also we removed from this project. If we switch to IntelliJ IDEA, you will be able to see better. So in the cloud gateway, in the pom.xml file, you can see we had removed the dependency. Okay, now let's go to the config server. In the config server, let's go to the pom.xml file. And from the pom.xml file, we will remove this Eureka client dependency. Okay, because we don't need it. Let's remove this. Let's rebuild the project, and we will go to the main resources and application.yaml file, and here we have the configuration for the Eureka. So this is also something that we don't need. So we will remove this as well. Okay, and in the Java main configuration, okay, there is no enable Eureka client, so this is all fine. Now let's go to the order service. So within the order service, let's go to the pom.xml file, and within the order service we have also implemented the test cases, right? And that test cases uses the service registry. So if we see here in the test cases, we have created the test service instance list supplier, right? This is something that we need, but we want to remove the Eureka. So for this, if you go to the pom.xml file and we go to the dependency analyzer, and if we search for load balancer, you can see that Spring Cloud load balancer is there, and this is part of the Netflix Eureka. But we want to remove the Netflix Eureka, but we need load balancer because load balancer provides us the functionality for the test service instance list supplier that will allow to implement our test cases that will contain multiple service registries. Okay, so for that reason we will remove this Netflix Eureka client, but we will keep the load balancer. So here what I will do is I will go to the Netflix Eureka starter and I will change to load balancer. Okay, now once that is done, once we have added the load balancer, we can go to the resources, and if you go to the application.yaml file, is there anything related to the Eureka server? No, that's all fine. If we go to the main resources, is there anything here related to the Eureka? This is already commented, so this is all fine. If you go to the Java, in the main This is only Fin client, so this is also fine. So we have removed the Eureka client dependency from the order service as well. Now let's go to the payment service and let's remove from there as well. So we'll scroll down here and we'll go to the Eureka client and we will remove this Eureka client dependency. Okay, now let's check with the SRC main resources. Is there anything here? Nope, all good. If you go to the Java, if you go to the payment service application, here is also all good. Now let's go to the product service. Let's go to the pom.xml file and let's remove the dependency of the Eureka client. So if you scroll down, this is something that I need to remove. Let's remove this and we are good here. So you can see that from all the project, we just removed the dependency of the Eureka client. Now in the next video, we will add another configuration related to the Kubernetes services. Now let's add the configuration for the Kubernetes services so that all the different microservices can connect. Till now everything was connected using the service registry. Now we need to connect each and everything using the Kubernetes services, and internally service registry of Kubernetes will take care of everything about the load balancing and everything. So all the services that we have used are mentioned in the cloud gateway. So if we come here in the cloud gateway in the SRC main resources and the application.yaml file, if you come here, this is all we have defined. That this is load balance order service and this was coming from the service registry, but now we need to use using the Kubernetes services. So we need to change this configuration. Now rather than calling the load balanced order service, we need to call the Kubernetes service, and the Kubernetes service that we have defined here, if you come here in the Kubernetes, we have defined that order service is going to be order service SVC. So this is something that I have to use. So if I just give this order service SVC here, and rather than load balance, I'll give HTTP. So now you can see that we just change the implementation. Rather than using the service registry, now we are using the Kubernetes service. Okay, the same thing we have to use everywhere. So order service is done. Now we have to use for the payment service. Now we need to give for the product service. So let me give for the product service as well. Okay, now for all the services we have defined that we should be connecting using the Kubernetes service. So all the configuration is done here. Now within the order service also we have defined the external clients, right, using the Fin client. Like from the order service we are going to call the payment service and the product service using the Fin client and the REST template. There we have defined the service registry names, right? So if we come here in the order service SRC main Java external client and payment service, if you come here you can see that we have defined that we should be calling the payment service /payment. So now rather than calling the payment service here, we should be calling using the payment service SVC, that is the Kubernetes service. Okay, so let's change it. So rather than giving the name here, so what I will give is I had to give the URL now. Okay, and what I want to do is this URL I'll be using it multiple places, because I'll be using it Fin client, then I will be using with the REST template as well, and I'll be using with the test cases as well. Okay, so I'm going to use at the multiple places. As I'm going to use at the multiple places, I can define in the properties file, and from there I can reference. So let me go to the properties file and let's define those first. So here let me define those properties. So here I'll define microservices colon, and within this microservices let's define the product service. Okay, and here I can give the URL, and here I can define payment, and here I can give the payment URL. For the product, let me give the URL, that is http:// product service SVC, that's the name of the service, /product. Okay, we are going to call the product. Similarly, let's add for the payment, and for the payment as well we have defined the same thing, http payment service SVC /payment. These are just the base URLs. Now this properties I can use in our external service. So let's go back here, and here I can use this way, and here I can use microservices dot, and this is going to be your payment, so dot payment. Okay, so we just define this. Okay, and this is something we need to add in the quotes. And for the name of this Fin client, I will just change to payment. Simple thing. I will copy this Fin client, and for the product service also I need to do the similar thing. So let me just add here, and I will just replace with the product here, microservices.product, and the name as product, and I will remove this. Okay, so you can see for Fin client, we have defined that we should be using the product service SVC and the payment service SVC. Those two are the Kubernetes services. Now, similarly, we need to change in our REST template as well. So if we go to the services and the order service IMPL, here we have used it. So if you scroll down, you can see that here we have used it. That is the product service / product and the payment service / payment. Okay, so this too is something that we need to change. So let's define it. So first we need to get the properties from the application.yaml file. So first let's define that. So here I will be defining it. So let me define private string product service URL and private string payment service URL. Two properties I have defined, and these two properties we will get from the properties file. So for that we will be using the @value annotation, and within this we can define $microservices dot product, and similarly here @value within the quotes $microservices dot payment. Okay, these two URL we have defined. Now this two URL we can use here. So let me just change it. We are calling the product service here, right? So rather than calling this product service, I'll be passing just the product service URL plus order.product ID. And here as well, what I will do is I will just pass the payment service URL plus, and I'm going to change all this / we have here, right? And we are going to append the order/order ID. So you can see that we just change the information here, all done, right? Now similarly we have to do the changes in our test cases as well. So if we go to the test cases in the test folder, if we go to the resources, okay, here also we need to add. So let's copy from here. Okay, so we'll copy this properties and we will add in the test cases as well. Okay, and for the Eureka we need to remove because we are not using Eureka anymore. So let's remove that. Okay, our properties are defined for our test cases as well. Now if we go here in the Java, if we go to the test service instance, here we have defined the payment service. So here this payment service is related to the service registry that we have added, but now we need to convert to the Kubernetes service. So we need to change this payment service as well and this product service as well to point to the product service SVC and the payment service SVC. So let's change it. Okay, so this payment service will be changed to payment service SVC, and this will be also changed to payment service SVC, and this product service will be changed to product service SVC and product service SVC. Okay, all things are done. Now if you go to the order service config, I don't need this bean anymore, so I'll just remove this. Okay, and if I go to my service layer, okay, so if there is any URL used here, we need to change it here as well. So you can see these are the URLs that we have used. These are the product service and the payment service. These are part of the service registry. So this is also something that we need to change. So let's do that. So what I will do, I will create properties here, that is the private string product service URL and private string payment service URL. So these two URLs I mentioned. I can get the values with @value annotation, and with dollar I can define microservice dot product. Similarly here I can define @value dollar with curly braces microservices dot payment. Okay, all the two values are now added here. So this two I can define here, that I need to call the product service here, and here I need to call the payment service URL plus I don't want this, I need till order. Okay, so all the two URLs are mentioned. Now one more thing we need to do here is, it's really important, because in the order service, like when we are calling the order service in the get order details, okay, if you go to the implementation, okay, here we have two properties defined, right? So these two properties also we need to assign when we are calling the test cases, right? So for that reason what we have to do is we have to go to our test cases, and using the reflection we need to assign those values within the order service. Okay, currently within this order service test we got these two values, but in the actual object also we need to assign it, right? Then only we'll be able to call. So here we need to do that. So let me just define one method to assign those values. So I'll just define one method, public void setup. Okay, and this method will be called before each method, and here with the reflections we'll be assigning those values. So with the reflection test utils, okay, dot set fields, in the order service we need to assign some properties. So what we need to assign, we have product service URL, right? So this is something that I need to assign, and with what I need to assign, with the product service URL, right? Again with reflection utils dot set field, in the order service I have payment service URL. So this I need to assign this value with the payment service URL, whatever the value it is. Okay, so currently you can see that I'm just setting the values, like whatever the values that I got from my application.yaml of the test instance, that I am attaching in the order service, because in the order service also I have these two fields and I need to assign these two fields because those values are coming from the properties files. Okay, so this is all I have defined, and I have changed the values. So I change the values here, I need to change the values here as well. So let me just change the product service URL, here also payment service URL plus. Okay, so you can see that everywhere we have changed the values. Now everything is pointing to the Kubernetes services, not the service registry. Everything is now with the Kubernetes service registry. Now all the configuration related to our project is done. Now we need to build everything and we need to publish to our Docker Hub. So let's do that. So what I will do, I will open the terminal for the cloud gateway and I will do mvn clean install zip build. Okay, it is running for this. Let's do for the config server as well. Same command, let's do for the other service as well. Open in terminal, let's do this order service. Let's do for the payment service as well. Open in terminal, let's do for the product service, and service registry we don't need. Okay, so let's check everything is done or not. You can see that this is done, cloud gateway is done, config server is also done, order service is running. Okay, let all these things completed. So we'll wait for that to complete. So you can see that everything is complete, all the builds are successful and all the new images are created and published to the Docker Hub. Now in the next video we will do the configuration related to the Kubernetes files. So now in all our Kubernetes files everything should point to the Kubernetes service registry rather than the service registry itself. So we have this service registry created, right? So this service registry I don't need because we are using the inbuilt service registry, right? Kubernetes. So what I will do, I just delete this file. I don't need this. Okay. So now service registry is gone. Now we need to make sure that we do not have the Eureka server address as the environment variable as well, because in every file we have added that as an environment variable as well. So if you go to the cloud gateway, you can see that we have the environment variable, right? That is pointing to the Eureka server address. So this is something also we don't need. So we can remove this. So now you can see that nothing is related to the Eureka server. If you go to the config map, we can remove this as well. Okay, we don't need this config map. That was the Eureka server. Next we'll go to the config server, and here also we don't need this environment variable in the config server. Okay, we'll remove this. We'll go to the MySQL. This is all okay. If you go to the order service, in the order service we don't need the Eureka server dependency, so we'll remove that environment variable as well. We'll go to the payment service, and in the payment service also we don't need, so we'll remove this as well. Okay, and if you go to the product service, same way we will remove that. And Redis deployment is going to the same, Zipkin deployment is going to be the same. So now we have removed all the dependencies of the Eureka server and everything should be pointing to my service registry. Now what we will do is we will deploy each and everything and we will see everything is working fine or not. Okay, so let's go to the terminal here. let's clear it out everything. Dashboard is open, that's fine. We can stop this services and clear everything. We can again stop this service also and clear everything. Similarly here as well. Okay, all the services are stopped now. If we go here, only dashboard is running and currently no resources are available. So if we see with kubectl get all, nothing is running. Okay, everything is cleared. So now let's deploy everything. So we'll just do kubectl apply -f Kubernetes folder. Okay, and you can see that everything is created. Okay, now if we go to the browser and if we go to the dashboard, you can see that everything is coming up. We will wait for everything to come up. So now you can see that everything seems to be green, so everything is up. If we go to the Statefulsets, we have only MySQL, no Eureka server. Okay, similarly replica sets, we don't have anything related to the Eureka server, only our services and the MySQL, Zipkin and Redis. Okay, so everything looks good and everything should be now connected to the service registry. Okay, now to check it, what we will do is we will go to the terminal, we will go to the services here, we'll just check kubectl get services. Okay, here we are getting all the services. Now we will just expose our cloud gateway, and from that cloud gateway we should be able to access all the services. If we are able to access the cloud gateway, and from the cloud gateway if we are able to call the product service or order service or anything, that means everything is working completely fine. So let's expose the service. We will just use minikube service and we will give the cloud gateway service. So let's give this and it will open the tunnel and we'll get the URL as well. And now once we get this, we again need to go ahead and change the port information here. So we will go here, we will go to the Okta. In the application, we will go to the applications and we'll go to our microservices application, and here in the general settings we will edit and we need to change the port information. So the port information is 56945. So we'll just change it 56945. Yeah, correct. And we'll copy this and we will save the changes. Okay, once this is done, we'll open a new window and we will call the login API. So it's authenticate/login and we should be able to get the login page. So we can see we are getting the login page. Let's log in with the user. So let me go to the directory people and let me get the email ID. So with this email ID I should be able to log in and I should be getting my access codes. And you can see that I got my token as well. Now with this token we should be able to access. So let me just copy this token here. Okay, and if I go to my postman and if I check with the post and I am passing the body here and I am passing the header information, sorry, not header, authorization, auth to token, request header, and I should be giving the token. So let me just paste the token here. And now if I hit the send, you can see that the port information is wrong. So let me change the port here. So it's 56945. Okay, so let's hit on send and you can see that I got the request, the data is created. So if I go ahead with the request 4 and if I do get here, I should be able to get the data as well. You can see that I'm getting the data. So that means my services are internally connected using the service registry of the Kubernetes, because we have everywhere defined this service only. Nowhere we have deployed the service registry and everything is working fine. Cool, right? So you can see that this is all about working with the Kubernetes using the inbuilt service registry. We are not using anything else, and this is how you will be able to deploy each and every component or each and every resources that you create in the Kubernetes cluster. It is really easy to work with the Kubernetes. You just need to create files, and with a lot of plugins you will be able to easily develop all these files. So here you have seen that we have gone through the lot of details about this Kubernetes course. We learned a lot of different things. If you have any doubts regarding any of the things that we have covered, then do let me know in the comment section below. We have added all the links to each and everything in the comment section below, so you can follow each and everything. You can follow the code structure, the documents, and each and everything. If you have enjoyed this course, then give us a thumbs up and subscribe to my channel for the upcoming videos. We are gonna put a lot more different courses in this channel, so you don't miss out on those as well. I will see you in the next video. Till then, happy coding. Bye bye.